Okay, guys. Good morning. Hopefully you guys can all hear me. And so, I'm sure some of you are getting used to the WebEx system, and you'll find it's pretty easy to use. But so what I normally do, just a few things about WebEx. So first of all, let me know if you can't hear me or if you can't see something. And there's depending on what if you're using a phone or a laptop or a tablet, it's pretty similar. But you should have the chat feature. And so as you can see the chat feature where I've been posting things, that's I found with a big group, that's probably the best way to communicate. And so what I usually tell students when we start is to try to mute your sound. So turn your sound off normally, but if you have a question, you can turn your sound back on and ask it. And that way we can't hear all the background noise from all the different locations. So if you have a question, turn your sound off. If you have a question, turn your sound on, and you can go ahead and speak whenever you want to. But if you don't have a question, try to turn your sound off so we don't hear all the background noise. So I think most of you turn your sound off, but there's still a few that need to do that. And if you have any questions, I keep the chat room feature open at all times. And so post any questions or comments to the chat feature, and I'll respond to those normally immediately. So you can all see did everybody see the chat feature?
我听不清你在说什么。对，现在就没有我们这种另外一个。
I don't want to mute everyone because in case you have a question, you won't be able to talk. So this seems fine. Okay, good. All right, so I think it's fine if I don't mute everyone. Right, let's do that shit. Okay. All right. So have you guys? There we go. Have you guys used WebEx before? I know we started using it in the spring semester after the spring break, or actually for you guys the beginning of the term. But if you took a class at Laverne or anywhere in the spring term, you probably use WebEx or Zoom or something, because we've had no on-ground classes since early March. And so you might be familiar with this. If not, hopefully you pick it up pretty quickly. But this is kind of the system or the software we're going to use. And it's available through your Laverne account. Okay, so looks like most students are here, but we still have a few that need to join. And so if you have any issues with Blackboard or WebEx, let me know. And I am going to recording all of our sessions. So if you miss anything or get logged off or have to go away for a minute, I'll record everything and I will post it on my YouTube channel, and you can see it there at any time. So if you miss something, you didn't lose it forever. It's being recorded. So just know that you can always access the video at a later date. Okay. So everybody can access the Blackboard page, I assume, and so we'll start doing that in a minute. And so I know that I had at least one student that wanted to talk about the meeting time. Okay, let me see if there's any comments I need to address. Okay, looks like we're good so far. So you saw this. I don't know if you guys have taken a Saturday class before where it's like every other Saturday, like this one, and all day. Let me try to fix this now. All right, I'm going to try to figure out how to mute everyone else, but I'm not sure how to do it.
Yeah. Mm-hmm. Mm-hmm.
Okay, so let's see.
这啥？这就是这种感觉，这也是个垃圾。
把那个字给撕了，让人联系方法。
Okay, so Gianeri Nong, like NONG, can you mute your audio feed?
感觉是断了吧？
Okay, I think I did it. Okay, so sorry, there was one of you that had background noise, so I think I muted you, but I can unmute you and you can post to the chat. Okay, so before we start with the syllabus and the Blackboard page, let's discuss, or let's talk about the meeting times. And so you know that the schedule was 8:30 to 4:30, which is 8 hours every other Saturday. Obviously, that's way too long for any meeting, but it's definitely way too long for doing online WebEx meetings or Zoom. And so I figured that if we're just lecture time or meeting time, then I probably need, instead of the 8 hours, I probably need 4 hours of WebEx time to cover all the material. And so I just wanted to start with something that I picked initially, that we do 2 hours in the morning and 2 hours in the afternoon. So the default schedule that I picked was 8:30 to 10:30 and then 1 to 3 with a big break in between. And now that's what I thought would probably be best, but if you guys want to do something better, I'm open to that. So I know that I had one student suggest that she would prefer to have it kind of all done more without a big break. And so I can try to do that. And so what are you guys' thoughts on the meeting times? Do you want to keep it how it is? Do you want to propose changes? Do you want to do, what do you guys think on that?
So, Professor, with me, I had emailed you about the suggestion, and so to all the students, my suggestion was that we do 8:30 to 10:30, and then take 30-minute break and come back, so that way it's just straight up, with a 30-minute break rather than an hour and a half. Especially considering students who are out of country, if there is anybody, that way, international hours-wise, it will be easier, I assume, than having you wake up again at 4 in the morning or so. But of course, whatever the majority is, I'll go with that.
So you say, let's see, so basically 8:30 to 10:30 and then 11 to 1?
Right.
All right, let me put that in the chat, and then so what we have now, let me write to what we have initially. If you have any comments to what Mary just said, please either post that to the chat, or we'll decide in a minute, but let me post the two options so far. Okay, that's another option.
I'm not a huge fan of that option. Same here.
Okay, so here's what I have now. So 8:30 to 10:30 a.m. and then I have 1 to 3. So So that's the current schedule, which I'm talking about. What Neri proposed is 8:30 to 10. And then 11. Okay, so these are vastly different options. All right, so maybe it was. I mean, I don't know I don't know that we're gonna reach a majority, but we're gonna have to do something, or else just keep it how it is. And so 8:30 to 1. Okay, so what do you guys think of? Or does anyone, first of all, does anyone want to keep it? Does anyone like how I set it up? Do you like? All right. Does anybody want to keep it as 8:30 to 10:30 and oh boy, that's just gonna be. Okay. Well, it looks like the two favorites are 8:30 to 1 and 1 to 5, which are completely different. I mean, well, first of all, I don't want to do it outside of the. It has to be within 8:30 to 4:30 because I'm not supposed to schedule anything outside of what the schedule says. So you can't do 1 to 5. We could do 12:30 to 4:30, but. All right, so we're gonna have to decide. So it looks like we have students, and I'm not gonna do both, but I'm gonna have to do either one or the other. I guess the majority's gonna win. But there's okay. So let me propose this one again.
That last one was a tiebreaker.
Did you count the votes? Are you gonna be my annotator?
No, I actually didn't, but I can.
Okay, so let's do it this way. So we'll first vote for 8. Well, first, okay. So there's 8:30 to these are completely different. So 8:30 to 1 or 1 to 5. It's like the opposite. So before we vote, anybody can you not? Is there one of those times you cannot do? So if you can't do one of the others, then I'm not gonna propose it. But
it's 6 to 8, Professor.
What?
The votes are 6 to 8. 6 for 1 to 5, and I think 8 for 8:30 to 1.
Okay. So the majority is voting for 8:30 to 1?
Yeah, looks like it.
Yeah, so, I mean, I prefer to start earlier. I know that some of you don't want to get that early in the Friday, but
I'm okay starting at 9, but as I said, 1 to 5 is definitely out of the schedule, so we can't schedule that because it has to be within 4:30.
all right. So let me write what I think the majority wants, and then I want to make sure that everybody can do it, and that there's no So 8:30. Okay, so 8:30 and 10:30, and then 11 to 1, so that'll cover the 4 hours, and we get a quick break in between. Okay, so if we do 8:30 and 10:30, and then 11 to 1, if we decide on that, I'll just keep the meeting going, and I'll assume you guys are going to come back. If you decide to log off and log back on after 3 minutes, we're going to have some issues. So if you want to do this like this, you have to have the WebEx logged on the whole time, and so that's going to be 4.5 hours. So it looks like most people went 8:30 to 10:30 and 11 to 1. So not preference wise, but can anybody not do that? Is there anybody that can not do that? And so that's what I need to know. So if there's any problems, like having time to get on WebEx, having a place to be there for 4.5 hours, let me know right now, because if there's problems doing it, then we have to change it. So can everybody do that? Or just tell me if you cannot. Okay, so it seems like everybody can do it. You might have to get it a little earlier than you prefer on your time rate, but it's only 5 times. This will be fun, right? Okay. All right. So should we change it to that? So we do. Then you'll be done by 1. So we'll do 8:30 to 10:30, and then 11 to 1. Okay. So do you guys want to do that today, or do you guys want to do that starting next time? Because I don't know if you need plans today, and so if you plan on doing something from okay. So it looks like everybody can do that, and I'll have to send another email because there's some things I haven't got here. And all right, so if you have any issues with it, please let me know right now, or just post it to the chat or say something. But we'll plan on that, and I'll send an official email later. But I'll cancel the so if we finish at 1, you're gonna get a reminder saying that there's another meeting scheduled at 1 to 3. So I'll cancel that later today or tomorrow, so just ignore that. And then I'll change the WebEx meeting to 8:30 to 1. Okay, so we'll be done today. Well, but maybe we'll be done before that, but we're done by 1 o'clock at the latest. Okay. All right. Everybody's good with that? Sounds like we agree. Okay. So it looks like, I know some of you want to do it afternoon, but I think I have to go with the majority. And this is how democracy works, right? Yeah. Okay. So we'll do 8:30 to 10:30, and then we'll take a 30-minute break, and we'll do one. Then we'll come back at 11, go to 1, and then we'll be done for the day. All right. And so that'll be 4 hours. And you guys know the meeting times. I'll change the WebEx schedule, but everything else is the same. Okay. And so again, if there's any issues, if you don't have a space to do it for that time, please let me know. But I think we're all okay. All right. So that's decided. And okay. All right. I was concerned that there would be like a tie. Okay, so let's, everybody can see the Blackboard page, I'm assuming. Okay, and the Blackboard we just updated to Blackboard Ultra. And so I don't know if you guys have that, but the page is a little bit, it's pretty much the same, but it's a little bit different. And so you can notice that it's now Blackboard Ultra, but it's pretty similar. Okay, so let's go over the syllabus. Okay, so on the Blackboard page under syllabus. Okay, so this is Biz 525 Economics of the Firm. And so I know a lot of you have taken one of my classes before, probably 500B. I recognize some of you. And so if you don't know me or you haven't taken one of my classes, this is my full name, James Joseph Hoffman. I usually go by Jake. So you can call me that if you like. It doesn't have to be too formal. Here's my cell number in case you need to contact me not by email. So here's my phone number. I'm usually really good at responding to emails. So if you send an email, I should respond unless you respond in super late. But I'm usually really good at responding to emails. So unless there's an emergency, you can choose email. But I do have my phone number in case you need to contact me immediately. Okay, so the prereq, which you guys I'm sure have already cleared, is 500B, which some of you took from me or took it somewhere else or got the prereqs cleared for that. The text I'm going to use as kind of a guideline is this one. So it's Michael Bay, Managerial Economics and Business Strategy, the 9th edition. And so I usually say that, I don't know if so it's, I'll say it's recommended. It can't hurt, but I know a lot of students don't want to purchase a new textbook, etc. And so if you don't have the textbook today, that's fine. It's going to help you if you want to do the readings of the chapters and look at some more examples. And I think it'll help you with understanding the material. But I'm going to say at this point it's recommended but not required because I know your finances could be challenged during this time, and so I'll provide you with most of the information via the meetings in Blackboard, but it won't help, or it can't hurt to have it if you want some more information. Okay, so this is the text we'll be using, or I'll be using, and if you have it, you might as well keep it and use it. If you want to read the chapters and look at more examples, it's probably going to help you out, but if you participate in all the meetings and look at all the resources on Blackboard, I think you'll be okay in the meantime. It's only $15. Okay, yeah, if that's the case, you might as well do that. But okay, so $15 on Amazon looks like. I don't know what the price is of the bookstore, but that's the text we'll be using. And so, I mean, if you have $15, you might as well rent it, or share it or something. Okay. So that's the text, this one here. Let's go down and look at the schedule, or the tentative schedule. Okay, so the schedule will be the same regardless of the time change thing. And so we'll kind of break, I kind of had to combine 2 lectures into one because it's every other Saturday. So it's basically, each meeting will be 2 normal lectures, but it shouldn't be too bad. So today, we're going to do chapters 1 and 2, chapter 3, and then another elasticity homework that has to do with chapter 3. Okay, so this will be the tentative schedule, and normally, like the things that are assigned are due the next week. And so this is what we'll do today, chapters 1, chapters 2, chapters 3, and the elasticity homework. The next step will be due, or the assignments will be due next in 2 weeks. And normally, or not normally, but always, I have a space on Blackboard for you to post your assignments. Okay, so if you go to the Blackboard page and go to discussions, this is where you're going to post your assignments. And so I'll remind you later, but every time we introduce an assignment, you'll just go to the space where, like the chapter 1, 2 homework, you just go here, and you create a thread, and you just post your assignment there. So the normal homeworks, that's where you'll post your homework. Okay, so this will be the schedule, and so basically you'll have a few chapter homeworks, and then I have a few like more data analysis homeworks. This one here, and then this one here. And so the normal schedule is the assignments or midterm is due right here, and then the only difference is after our last meeting on Saturday, August 8th, the only thing you have to do after that is the take-home final and the take-home oligopoly homework, and that'll be due by the next Thursday, so you have a little shorter time, but you should have plenty of time to do those things. And that way I can get your, I want to get all your grades in by August 15th, and so if you guys can give me all your, just the last 2 assignments by the 13th, all your grades will be in and recorded by August 15th. Okay, so this will be the tentative schedule, and we're going to do the book chapters, a few extensions that I made different homework for, and you have a couple, there's going to be no, obviously no in-class exams, but you have a take-home midterm, which will be due July 25th, so that's a ways away. And then a final exam, which is due Thursday, August 13th. So the normal meeting times are the normal due dates. The only difference is the last one, so the final date is Thursday, August 13th. Okay, so this is how I broke the grading down. So you'll get I put 5% for the WebEx meetings, so pretty much as long as you attend the meetings, or even if you miss some of the meeting and make up watching it on the YouTube channel, you can do that. And so I'm assuming everyone's going to get, I'm assuming most students are going to get full attendance. And so let me know otherwise. So it looks like most students are here. If you miss a few minutes or so, you can make it up on watching the YouTube. But other than that, please try to come because it's easier when students are here. So most students will get this 5% because all you have to do is come to the meetings. Okay, and the homework will be 45%. So there's a number of assignments, but you get plenty of time to do those. So I think there's there's a number of homework assignments, so that'll be 45%. And we have 2 exams, so one exam, the midterm is 25% and the other is 25%. So this is the breakdown. And so most of your, pretty much the bulk of your grade is the homework assignments and the 2 take-home exams, which are like, longer homework assignments and Okay, and I will change this because you guys decided that you wanted 8:30 to 10:30 and then 11 to 1. So I'll just change it to that. So ignore this for now, but the meeting days are the same, but it's now 8:30 to 1 with a 30-minute break. Okay, so any questions on the syllabus? or anything thus far that we've talked about?
I think we're good.
We're good? Okay. Okay, so again, if you have a question or a comment or want to ask anything to the class or to me, you can do one of two ways. You can post in the chat, which I'm always looking at, or you can unmute yourself and ask it. You can always, you're welcome to talk whenever you want. Just take yourself off mute, ask your question, or you can always post in the chat. So, okay, so let's start with what we're going to do today. So we'll start with chapters 1 and 2, kind of an intro to the course, and then a review of supply and demand. And so this will be our first section. So I want to finish this by just 10:30, and then when we come back at now 11, we'll do chapter 3 and the elasticity homework. And so this, I know that the elasticity homework, we're going to do a little bit of analysis in Excel. And so does everyone have access to like Microsoft Excel or somewhere we can do some spreadsheet analysis? Because we're gonna do some elasticity estimates. So does everyone have access to Microsoft Excel?
Yes.
Okay. Or let me know if you don't, and I'll try to. Okay, seems like alright, so it seems like everyone's good so far, and let's go ahead and start doing the chapter 1 and 2 material. Okay, so let's do good. Alright, so if you go down to, I have the chapters materials here, with the homeworks and kind of the study guides, the notes that I made from the chapters. And so let's start by opening up the chapter 1 and 2. Okay, and so I think let's open up the chapter 1 first. Okay, so these are some practice problems we'll get to in a minute. And then if you want to go to, on the Blackboard page, you see PowerPoint. And you can open up the chapter 1 PowerPoint. Okay, and then because I have the newest edition of the textbook, but I couldn't find a PDF of the new one. But I did pick this one that I'll need to refer to in class sometimes. And so I'm going to open up this for now, and this is the 7th edition of the textbook, and it's different. There's been a bunch of updates, but kind of the main graphs are the same, so I might need to refer to these graphs or equations. Okay, so other than that, that's normally for the chapters. I have some notes and practice problems as study guide portion. In the appropriate chapter, I have a homework. I have a PowerPoint, and then we'll use some of the PDF textbooks to look at the graphs, etc. And then the rest of so before we start, there's a bunch of videos that are optional, that I'll point those out from time to time. There's some old exams you can look at for practice if you want more practice. And then this is a link to the YouTube page I started a few months ago. And it's just a bunch of my recordings. So if you click on this, and then you click on playlists, you want to go to the one, obviously, for Biz 525, and I'll post I'll just click on it so you see, but okay, so I'll organize them by date, and this is the last recording from the spring term. But I'll post one. The first one will be for today, and so you can find after the meetings are done, I will post the whole thing on this YouTube channel, so you can go to the Biz 525 folder or playlist, I guess, and just look at the one by the date, and then whatever date it was, that'll be that recording. So you can access all the meetings right here. Okay, so yeah. All right, so let's start chapter 1. Okay, so chapter 1 is kind of the intro to the subject, which is managerial economics. We're not going to, all the videos will be kind of optional now because a lot of times in class I show videos from time to time, but I don't think it's probably not a good use of our time to show videos during WebEx. So this is optional, but there's a bunch of videos I'll point you to if you want to look at those. Okay, so what we're going to do in this class is kind of build on the concepts we learned in Intro to Econ, Biz 500B, in particular the microeconomics of the firm and firm behavior, and how consumers respond to firms and how firms respond to consumers. So this will be exclusively a microeconomics course, focused on different firm behaviors and different types of markets, and how both sides kind of make decisions. Okay, so this is how scarce resources are directed in a way that achieves some managerial goal, whatever that is. Okay, and so just some more intro stuff is, so this is the kind of the 6 things that define an effective manager or effective management in the textbook. So what you want to do to be an effective manager, to go through these checkpoints, is you want to know your goals and constraints. So what do you want to get to, and what constrains you? Like, do you want to maximize your profit? Do you want to minimize your costs? Do you want to achieve some goal? And then what are your constraints? How much labor do you have, etc. So first, just identify what you're trying to get to and what you're constrained by. Okay, and you want to recognize the nature and importance of profits, because that helps dictate if the firm should, produce more, hire more workers, do less, and we'll look at that when we look at the different cost curves. Okay, you want to understand the incentives for both your workers, your customers, and so on, depending on the market that you're in. Number 4, you want to understand the market you're in. So depending on the type of market that classifies your current business, and we'll talk about these in chapters, I believe 8, 9, and 10, but depending on the type of market, that dictates or helps you determine what you should do as a firm. Okay, you want to look at the time value of money, which we're going to look at in a couple of practice problems in a minute, because that if you need to borrow money, that you have to pay an interest rate, or if you want to lend money, that you get an interest rate, and there's a calculation that determines how much money is worth today versus how much it's worth in the future. Okay, and then because this is microeconomics, everything is done on the margin, so we're going to look at a lot of marginal decisions. And if you produce one more unit, what happens? If you hire one less worker, what happens? And so on. But marginal analysis is really important because things on the margin change from time to time. Okay, and briefly let's revisit accounting versus economic profits. And so you probably learned this in any introductory econ course or in 500B, but just to clarify the difference between an accounting profit and an economic profit is here. So an accounting profit is just kind of your revenue minus your cost as a business. So if you're coming out ahead, that's an accounting profit. But we also have to factor in the opportunity cost. Okay, so if you're running a business or you're using a resource, then you also have to consider what you could have otherwise used that resource for. And so there's an opportunity cost to any business and any resource that you have to consider in your economic profit. So if you have, if you're operating a pizzeria and you're using a bunch of ovens and food resources for that, you have to consider what the next best option was as well. So, for example, if you're making a profit as a pizzeria, there's some amount, but someone offers to buy the equipment at a much higher revenue than the profit you're making, then it might be more profitable to sell some of the equipment. So you have to consider the next best option for any business, and that is the economic profit, which incorporates the opportunity cost. Okay, so formal definition is right there. So the opportunity cost of using a resource includes both the explicit, which is the accounting profit, and also the implicit cost of giving up the resource, which is the opportunity cost. So it's kind of accounting profit plus the opportunity cost. Okay, so a few more intro things, and then we'll start looking at examples. Okay, so the 5 categories or forces from the textbook that impact the sustainability of your industry profits. So number 1 is entry. How easy is it to enter or exit the market you're operating in? So we know that depending on the type of market, like for a monopoly market, it's very hard to enter. And that helps you determine what you want to do as a firm or a business. How much power do your input suppliers have? And so we've seen this, kind of play out in the current gasoline or oil market. And so you know that barrels of gasoline are the main input to like a gas station or anywhere that sells a gasoline-induced product. And because of the shortage of supply, this became a big problem, and the power of the input suppliers helped determine and helped figure out why some of the oil prices were so low recently, and in some cases negative, because the input suppliers had to sell the barrels or sell them in the future, and because the demand for those barrels there wasn't enough capacity to store those, that had a huge role in what happened to that final product. So you're going to look at not only the final good, but what goes into the main inputs that go into that resource or that good or service. Okay, and then also how much power the buyers have, depending on what type of market or good or service you're looking at. So if your buyers have more options, then you have to be more aware of what they can do or shop around. If they have less options, then you have more control, or they have less power as a buyer. Okay, what are your rivals doing? If you're Microsoft, what is Apple doing? If you're Coke, what is Pepsi doing? And so what happens, or what your rival is doing helps you, or you want to be aware of what you need to do, or if you want to respond or not. And we'll look at a lot of that in the game theory material in, I want to say, chapter 10. Okay, and then substitutes and complements. We learned about these terms, I think, in Biz 500B. So substitutes are goods in which you can interchange them, or the consumer has pretty much the same preference for both, like Coke and Pepsi, or what else is a substitute? But things that are like, or iPhones and Androids are things that can be used in substitute of the other. Okay, and then complements are goods in which you consume together. and we learned about these, like ketchup and mustard or milk and cereal, or things in which the consumer would need to have both things in their consumption bundle. Okay, so let's introduce present value analysis, and then we'll do a little example of this. And so the present value of an amount received in the future is the amount that would have to be invested today at the current interest rate that generates the given future value. So this helps you determine what the payment or the good is worth today if you factor in the future interest rate or the current interest rate and how that plays out in the future. Okay, so the present value of the future value received in n number of years or periods looks like this. So your present value is the future value divided by 1 plus I, so 1 plus the interest rate, and raised to the n, and n is the number of, or the current period. So the longer you wait, the lower the present value is. Okay, and then, so like I just said, the higher the interest rate, the longer you wait and the higher the interest rate, the higher the interest rate, the lower the present value of the future amount. And conversely, so if this number is bigger, this I down here, that makes this whole metric smaller because the denominator is getting bigger. And so if it's a higher interest rate, then your present value goes down. And that's because if this is the present value of a resource or a value, then this is the rate at which you could lend at or get a return at some interest-bearing account. So this helps determine, for lenders, if you want to lend or if you want to invest, and if you're a borrower, if you want to invest in the product or just put the money into the account that earns that interest rate. Okay, so let's look at a stream of values. So the present value of a stream or number of payments. So when the interest rate is I, the present value of a stream of future payments is you add up all the future payments divided by that term in the interest rate. So it looks like this. So if you have n periods or n payments, you add up all those together, discounted by 1 plus I raised to the t or the current period. So it's just like the future value 1 plus the future value 2 and so on until you get all of the future values covered. Okay, and then net present value is, we're adding one more thing, which is the cost of the project or the good or service. So the net present value of the project is the present value of the income stream generated by the project, and then minus the current cost. So this is kind of the net present value or the cost-benefit analysis look at. And so if the net present value is, or if the present value is this, say the stream of payments, then the net present value is just that minus the cost. Okay, so if you have these payments, the future value in period 1, in period 2, in period 3, or however many periods there are, and then all you have to do to get the net present value is subtract the current cost, because you're trying to see if the project is worth the initial cost. So if the net present value is positive, or if the stream of payments exceeds the cost, you can go ahead and invest in the project. If it doesn't, you can just, what this says is you should just keep the money and put it into that interest-bearing account at the current interest rate. So this is you're looking at the trade-off of investing in a project or what you could otherwise earn at a bank account at that interest rate. Okay, so net present value is important, and let's look at a little example. Okay, so this is demonstration problem 1-1 in your textbook. And so a lot of the practice problems, or most of them, I did separately, so we can go through them. And then you can use these for your so as an example for your homework. So if you go to the chapter 1 document, so I already opened it with this one here. Okay, so this is demonstration problem 1-1. I redid it in the Word document so we can go through it, and you can use this as your example. And so, like if you've taken one of my courses before, you know I did a lot of examples on the whiteboard. I don't have that resource remotely or via WebEx, and so I kind of had to redo everything in Microsoft Word. And so for your homework assignments, it's kind of the how you do your homework, or where you write your homework is up to you. So I did all the homework assignments and the exams and the projects, etc., in Microsoft Word and Microsoft Excel. And so if you want to use my examples to do it in Word, you can do that. Or if you prefer to write your answers and some of the homework, you know, just do it by hand on paper or graph paper, you can do that too. So most of my examples I did in Word because I want to be able to share it with you via WebEx. But if you prefer to do your homework just with graphing paper, or with a pen or pencil, you're welcome to do that too. Okay, so here's an actual video on net present value. Alright, and then here's demonstration problem 1-1, which is a nice example of the net present value problem. Okay, so the manager of automated products was contemplating the purchase of a new machine that will cost $300,000 and has a useful life of 5 years. The machine will yield year-end cost reductions to automated products of $50,000 in year 1, $60,000 in year 2, $75,000 in year 3, and then $95,000 in years 4 and 5. And then after year 5, the machine's done. Okay, what is the present value of the cost savings of the machine if the interest rate is 8%? Okay, so should the manager purchase the machine? Alright, so this is the formula that we just learned, or the standard formula for net present value. So you want to add up all the discounted future values, which is the future value divided by 1 plus the interest rate, and it's divided or raised to that period. So this is period 1, period 2, and then you want to subtract the cost. So we can use this simple formula to calculate the net present value of this new machine. Okay, so here we go. It told us that in year 1 it's 50,000, we get, and let's divide that by 1 plus the interest rate. So 1 plus 8% is 1.08. Okay, 60,000 in year 2, and remember in year 2 it's raised and it's squared. So now it's 1.08 squared for period 2. And then plus 75,000 for year 3, divided by 1 plus the interest rate to the third, so 1.08 cubed. Plus 90,000 divided by 1.08 to the fourth. And then finally the last payment in year 5 is 90,000 divided by 1.08 to the fifth. Okay, so that is the stream of payments, or the cost reductions that we get. And then the cost of this machine is 300,000, so we have to subtract that. So it's the payments, or the revenue payments, minus the cost. Okay, and if you put this in your calculator, you should get something like this. which is negative 15,321, something like that. And so that means that the payments that we got, or the cost reductions that we netted, weren't bigger than the initial cost. So the cost of this new machine was higher than the returns we gave us. So what this would tell us is that it's not a good idea for the manager of the firm to invest in this machine. So the manager should not purchase the machine because the net present value is 0, which means otherwise, if there was an option of an 8% return, that the manager should take the $300,000 and put it in the account that earns 8% instead. So that would be a better, it doesn't have to do that, but that would be a better option than buying this machine because the net present value is negative. Okay, so that was a nice net present value question or problem or example. Any questions on this? Everybody doing okay so far?
We're good.
Okay, I believe you. Okay, so let's move on to the next topic. And again, if you have any questions, just go ahead and ask them, or post anything you want in the chat. All right, let's look at, so we left off here, so next slide is on marginal analysis and net benefits. And so this is a nice, just general idea of how you look at kind of the net benefit, which is the benefit minus the cost of any project or good or service. And so this is an intro to this. This is kind of an intro to cost benefit analysis. We'll spend just a little bit of time on this. So in general, net benefits is the benefit of some output minus the cost. So if the benefit is something and the cost is something, then the net is the sum of the difference of those two. And obviously, if the benefit exceeds the cost, you have positive net benefits. Or if it's the other way, if the cost is higher than the benefit, then your net benefits are negative. And that depends on how much output or Q you choose for a project. Okay, and then on the margin, you're looking at the change. So the marginal net benefits are similar to that, and the marginal benefit minus the marginal cost of some output or activity is the difference there. So if your benefit exceeds the cost of the margin, then it's positive, and vice versa. Okay, so let me see if I can show you this figure from the PDF version of the textbook that I put on Blackboard. So figure 1-2. All right, there we go. Okay, so here's figure 1-2. And this is the same figure from the current version of the textbook. So this is just a little intro on determining the optimal level of a continuous variable, or sorry, control variable. And so this is Q is output, or how much you're choosing for all these graphs. And this top one is the total benefits and costs. This one is the net benefits, and then this one is the marginal benefits. Okay, so you can see they're all kind of related. Okay, don't worry about like memorizing the graphs. I just want you to kind of understand what's going on here graphically. Okay, so you don't have to draw these graphs, but so this is some output or activity, and this is how much you're choosing. So you can see that the cost is increasing, and the benefit from that activity is increasing, but kind of at a decreasing rate. And the point where they cross is right here. And so that's when the cost begins to exceed the benefit. Okay, so you can see here the net benefits after this point are negative from that point on. But what you're trying to do for a project or a manager is essentially maximize net benefits. So you want this distance to be as big as possible, because if that's the case, that means that your benefits are at the highest point from your cost, and you're getting the highest level of net benefits. So this distance is the biggest. Okay, and that should be the case, or is the case, when net benefits are maxed out at a slope of 0. So see how when this distance is at its highest, the net benefits are maxed out. Okay, so when this peaks, when your marginal net benefits peak, that's the best point for your total benefits. Okay, and that also relates to the marginal benefits down here. You can see that when the marginal benefit exceeds the marginal cost, that's also when you maximize your total benefits. Okay? So everything is kind of related. When marginal benefit equals marginal cost, that's when your marginal net benefits are 0. That's when you maximize your net benefits, and that's when this distance is at its biggest, and you get the biggest, the most benefits in relation to your cost. Okay, so again, don't worry about trying to replicate this, but it's a nice illustration of what these concepts show. Okay, so next is let's look at some examples of net benefits. Okay, so these are at the end of chapter 1 in your textbook. And so I redid these in the Word file so we can look at those there, but this we're doing at the end of chapter 1, under conceptual and computational questions, we'll do number 1. We'll do number 3, and we'll do number 9 as an example here. Okay, so after the net present value, let's look at these two examples. Okay, so number 3 at the end of chapter 1 is, let's suppose that the total benefit and total cost from an activity are respectively given by these equations. Okay, so here's the benefit as a function of Q. So the benefit as a function of Q is 150 plus 28Q minus 5Q squared, and the cost is 100 plus 8Q. And then the marginal benefits, 28 minus 10Q, and the marginal cost is 8. Okay, so let's use these given equations to answer the question. Okay, so let's write the equation for net benefits. And so net benefits, we just learned, is benefits minus cost as a function of Q. Okay, so net benefits would be this minus this. Okay, so 150 minus 100 is 50, and 28Q minus 8Q is 20Q. Okay, so in total, when you take away the cost from the benefits, you get 50 plus 20Q minus 5Q squared. Okay, and then part B, what are the net benefits when Q equals 1 and Q equals 5? Okay, so just plug in 1 for Q here. So net benefits when Q is 1 is 50 plus 20 times 1 minus 5 times 1 squared, so that's 50 plus 20 minus 5, which comes out to 65. Okay, and then net benefits when Q is 5 is 50 plus 20 times 5 minus 5 times 5 squared, so we get 50 plus 100 minus 125, which is 25. Okay, so all you're doing there is plugging in whatever value of Q it says to see what your benefits are. So you can see that benefits that our net benefits are somewhere in between. So 5 is too much, and it's either somewhere between 1 and 5 because the net benefits go down. Okay, now let's write out the equation for marginal net benefits. So that's just marginal benefits minus marginal cost. Okay, so this minus this, right? So it's basically 28 minus 8, so it's 20 minus 10q. Okay, and then what are the marginal net benefits when q is 5 and q is 1 and q is 5? So plug in q, we get 20 minus 10 times 1, which is 10. And when q is 5, we get 20 minus 10 times 5, which is negative 30. Okay, so you can kind of see the relationship between net benefits and marginal net benefits. So your net benefits are going to be maximized when when marginal net benefits are 0, and that's going to give you the highest net benefit. So we haven't found we've seen what it is in these ranges, but it's got to be somewhere in between. Okay, then E, what level of Q maximizes net benefit? So when marginal net benefits are 0, or the same thing as saying when marginal benefit equals marginal cost, that's got to be the case when your marginal benefits, or your total benefits are maximal. Okay? So let's take marginal net benefits, 20 minus 10q, and set that equal to 0. Okay? Or you can set marginal benefit equal to marginal cost and the same thing. So both of those results, or both of those methods will give you the same answer. Okay, so over here, we get 10q equals 20, and over here we get 10q equals 20. So same thing, and then if you divide both sides by 10, you'll find the level of q that maximizes net benefits is 2. Alright, so at the value of q that maximizes net benefits, what is the value of marginal net benefits? So it's got to be 0, but just confirm that put in 2 there, 20 minus 10 times 2 is 0. Okay, so you knew that the highest point was somewhere in between this. 5 was too much, and it looks like net benefits when q is 2 gives us the highest total benefit or net benefit of this activity. Alright, so let's do one more of these, number 9. Then we'll be done with the net benefits. So let's suppose that the total benefit and total cost from the continuous decision Q are these equations now. Benefits is 25 minus Q squared, and cost is 5 plus Q squared, where marginal benefit is 25 minus 2Q and marginal cost is 2Q. Okay, so what is total benefit when Q is 2 and Q is 10? All you gotta do is plug in 2 into the benefit equation. So B of 2 is 25 times 2 minus 2 squared, which is 15 minus 4, and that's 46. When Q is 10, you get 25 times 10 minus 10 squared, which equals 250 minus 100, which equals 150. So those are different benefits when Q is changing. Alright. What are marginal benefits when Q is 2 and 10? So plug in 2, 25 minus 2 times 2 is 21, and when it's 10, 25 minus 2 times 10 is 5. Alright, so what level of Q maximizes total benefits? And so we know that that's when the marginal benefit equals 0. Okay, so the marginal benefit is 25 minus 2Q. Alright, so if you look at the graph again, okay, so when the marginal benefit is here, the benefit is at its highest when the marginal benefit is 0, right? So that's what we're trying to show. Okay, so when marginal benefit is 0, that's 25 minus 2Q equals 0. If we solve for Q, we get 2Q equals 25, and Q star equals 12.5. Alright, so a few more on cost, and then we'll bring this home. So what's total cost when Q is 2 and Q is 10? Okay, plug in 2 for the cost equation. And we get C of 2 equals 5 plus 2 squared, which equals 9, and then plug in 10, 5 plus 10 squared, which is 105, and then for the marginal cost, what's that when Q is 2 and 10? Okay, plug in 2. Alright, so it's just 2 times 2. 2 times 2 is 4. And 2 times 10 is 20 for marginal cost for those two things. And then what level of Q maximizes total cost? And so that's when the marginal cost is 0. Alright, so if you look at the graph, the only situation in which marginal cost is 0 is when it's 0. So for the cost side, you know that you're going to minimize costs when it's 0. So you should get 0 here. And we do. So 2Q equals 0, and that's, we get our lowest cost when nothing's happened. So when Q equals 0. Okay, and then what level of Q maximizes net benefits? Importantly, so again, you can look at when marginal benefit equals marginal cost, or when marginal net benefit is 0, should be the same thing. So you can set these two equal. Uh, 25 minus 2Q equals 2Q, or you can get the marginal net benefits and set those equal 0, which are 25 minus 4Q equals 0. Okay, so if you solve this one, you get 4Q equals 25. Same thing here. So either way, if you divide both sides by 4, you're going to get that Q star equals 6.25. And that's when this activity or project is maximized, when Q is 6.25. Okay, so any questions on the marginal net benefit examples?
Professor, are these solutions posted on Blackboard too?
Yeah, these are what I'm reading you now is on Blackboard. Yeah, so these are my solutions to the examples, and you can use these for your homework preparation.
Okay, thank you.
So this document here, chapter 1 has the solutions that we just went through.
Got it. Thank you.
You're welcome. Okay, so everybody good on this? So we still have, so we're almost done with chapter. Actually, we're done with chapter 1 except for the homework problems, but we still have one more chapter to do. What time it is? You guys ready for, so chapter 2 is kind of a nice review of supply and demand. And you guys ready for chapter 2? So let's open up the chapter 2. Okay, we can open up the chapter 2 PowerPoint. Okay, so chapter 2 is a nice review of supply and demand, if you haven't done that for a while. So some of these concepts you might have learned in Biz 500B, but we need to review them before we move on to chapter 3. Okay, so chapter 2 is on market forces, which is all the things we need to know or review about supply and demand. Okay, so we'll do as much as we will. I'll try to finish this by 10:30, but if it becomes 10:30, just make sure you remind me, and we'll take a break then. So again, we're doing 8:30 to 10:30. We'll take a 30-minute break, and then we'll finish the rest starting at 11. So if I get to 10:30 and I'm still talking, then make sure you stop me. Okay, so here's an optional video on supply and demand that's in the chapter 2 PowerPoint. Okay, so just a review of demand. So the market demand curve, it tells us the total quantity of the good that all consumers are willing to purchase at each possible price, and holding everything else constant that also affects demand. So this shows you that there's a nice inverse relationship between price and quantity of a good or service in the market. Okay, so just to review the graph, okay, there we go. So there's our typical demand curve that I'm sure you're familiar with, but here's the price of some good or service, and here's the quantity demanded, and you should know that when the price goes up, the market demand goes down, and vice versa. When the price goes down, that the market demand usually goes up. Either consumers that are currently buying, when the price goes down, buy more of it, or some new consumers in the margin enter the market. Okay, so what if demand changes? So you know that if the price goes up or down, you're just going up or down the demand curve. So a change in quantity demanded is a change up or down the demand curve. So if you go from here to here, or from here to here on a given demand curve, that's a change in demand, or a change in the demand of the demand curve. So I guess we'll call that a change in quantity demanded, but if there's a change in the demand relationship between price and market demand, then that's a demand shifter. So if there's a change in quantity demanded, that's just a change up or down the demand curve when price changes. But if something else changes that affects demand, you know that that's going to shift the demand curve. Okay, so a change in a variable other than the price of a good, such as income or the price of a related good or something else that affects demand, is going to shift the demand curve up or down. Okay, so we're going to review some demand shifters, in particular the ones relating to income and the prices of related goods. Okay, so you guys might recall we talked about these concepts in Basic 500B, but income affects demand depending on the type of good it's classified as. Alright, so a normal good is a good in which an increase in income leads to an increase in demand. So there's a positive relationship between income and demand, which makes sense that if the consumers get more income, they buy more of that good or service. Okay, but we also had another type of good called coded as inferior goods. And so this is when there's an inverse relationship between demand and income. So when income goes up, demand goes down, or vice versa. If income goes down, demand goes up. So this was a specific type of good. So do you guys remember some of the examples of inferior good, or what's an example of an inferior good? Like why would consumers, what kind of good or service would consumers buy more of when they have less income?
Like a knockoff version of like a store brand of like a cereal or something.
Yeah, probably something like that. I was gonna say I was typing in something. I was gonna say fast food or canned goods. Like if your income goes down, you buy the cheaper food services or the goods that last longer, like canned goods, or like a powdered eggs or something. Or if your income went up, you might buy the more nutritious or things you prefer to consume. But if your income goes up and you buy more of these things, that probably has to do with the fact that they're coded as inferior goods. Okay? Okay, so yeah, I think we get the idea there. So we know that if, depending on the type of good, that's going to affect the demand curve differently. And so let's look at that. I think there's an example here. Yeah. Okay. So if this is our demand curve, and let's say that we have a normal good, and income goes up. So if income goes up, and we call this a normal good, like most goods are normal goods. Normally, if income goes up, the consumers buy more of it. So if this is a normal good, and income goes up, that's an increase in demand, or the demand curve shifts out to the right, showing that at any given price, the market buys more of it. So this is an increase in demand. Or if we were looking at an inferior good and income goes up, that by definition means that the market buys less of it. So this is a decrease in demand going this way. So increase in demand or decrease in demand, showing that at the original price, if there's an increase, the market demands more of it, or if there's a decrease at that price, the market demands less of it. Okay, so let's now look at substitutes and complements. Okay, so another type of demand shifter is the substitutes and complements category. So this is if there's a good that's related to the good we're looking at. So if we're looking at the price of related goods that relate to the market you're analyzing, we can classify those as two types. One would be substitutes. Okay, so these are goods for which the increase in the price of one good leads to an increase in the demand for the other. So think of substitutes as if the consumer is somewhat indifferent between buying the two goods. So if one gets more expensive, then the consumer or consumers prefer the cheaper one because it's a substitute for the other. Okay, so I think we've done this before, but what are two goods that might be a substitute for one another?
Bus or train?
Yeah, that's a good one. Yeah, so if you're trying to get somewhere via public transportation, not driving or flying, and you have the option between bus or train, and you don't really care which one you choose, then you're going to choose the one that's cheaper, right? So if it's currently either the same cost via bus or train to get somewhere, and you're pretty much indifferent between the two substitutes, and then the price of train goes up, you might opt or see a lot of consumers switch to bus because they still get to the same place, and the bus option is now cheaper. So yeah, that's exactly. Okay, and then complements have kind of the opposite relationship because these two goods, the consumer or consumer consumes together. And so goods for which there's an increase in the price of one good leads to a decrease in the demand for the other, and that's because you got to have both of these goods together or consume them as like a bundle. And so complements are consumed together; they're complementary. All right. So what's an example of two goods that might be complementary? What are two complements? So what are two goods? And you can always post your if I ask questions, you can post to the chat as well. Okay, so complementary goods you want to consume together, so like milk and cereal, maybe. Yeah, there we go. Shampoo, conditioner. Yeah, all those things are exactly, yeah. Right. So there's shampoo and conditioner, car and gasoline, or toothbrush and toothpaste. Yeah, so all those things you need to consume together, or typically are. And so what you see is and those are all good examples. So if you need shampoo and conditioner and the price of shampoo goes up, then you got to buy less conditioner because the price of that bundle has gone up. And the same for like gasoline and car. If the price of gasoline goes down, you probably drive more because it's not, or the quantity of miles driven, I guess, would go up because the price of gasoline is cheaper. So there's the opposite relationship you get with the substitute. Yeah. So you guys get the idea. So does it have to be goods only, or can service? Yeah, services too. So services like I don't know what's like iPhones and Uber or something.
Or something like hotel and some complimentary service with it. I don't know, like you book a room for so and so nights, and you get a complimentary. I don't know. For example, casinos, a complimentary play, $100 play.
Yeah, but I think that's kind of a different way to use the word complimentary, because that's almost like an add-on, or like that's like an additional feature. It's not a, it's complimentary.
Right, I see what you mean.
What?
I see what you mean. It's not a service that complements each other. It's a service that added to another one.
Yeah. So that's a different definition of the word complimentary, I guess. So that's definitely complimentary, but not with the term we're defining here, I guess. But but it can also apply to services. I mean, if you're looking at a good or a service, or if you're looking at I don't know, massages and massage recall tables, or massage oil and massages. So if you're consuming massages and massage oil, and the price of massage oil goes up, then so you can mix and match. So it can work for services as well, but don't think of it like in the add-on sense. Think of it like as you need to have them together.
Okay. Could it work too with like, say something that makes something? So like wheat to bread. Like, does it work that way too?
Well, that would affect the supply curve. I mean, I think that's when we get to the supply curve, that's like the relationship between well, let me think of it. So if you have like a bread maker and the price of wheat goes up or something, or the price of dough,
Mm-hmm.
that would work. Right? So if you're looking at but it's got to be two things that the consumer is directly consuming. So if you're making your own bread, and if you're only buying the bread, then it wouldn't work. That would be a supply issue. But if you're making the bread as a consumer, and you're buying the bread and the wheat, then yes.
Okay.
So if you're just looking at bread as a final good, then that would be a supply issue. But yeah, that would work.
Yeah.
Okay. Yeah. So there's all kinds of examples. Okay, so the same thing happens here is if we're looking at substitutes and or we're looking at the substitutes first. So if the price of we're looking at shampoo and conditioner, and the price of conditioner goes up, that's going to lead to a decrease in the demand for shampoo, because the whole bundle has gotten more expensive. And if we're looking at complements, right? So if we're looking at the last one that was given was if you're a consumer of making bread, and you need to get wheat, and you need to get let me think of this. It would only work if it's like two goods that you need to consume. So like a bread maker and like the dough that goes in. So if you have a bread maker and you need dough, then those are complements. Okay. So if the price of dough goes up, then you would consume your demand for bread makers will go down. So there's kind of depending on if it's substitutes or complements, your shift in the demand curve goes the opposite direction. So this way is always increase, and this way is always decrease. So you have to look at or pay attention to which types of goods you're analyzing. Okay, so so we did substitutes and complements. Okay, so there's some other types of things that can shift the demand curve. And, I mean, there's many more examples, but these are some more that were presented in the textbook. Advertising, consumer taste, population, consumer expectations. So if something, basically the idea is that anything that affects demand changes, other than the price, that's going to shift the demand curve the appropriate direction. Okay, so the main ones we'll focus on are the income ones, normal and inferior, and the related goods, which are substitutes and complements, but just know that there's lots of other things that also affect demand. Okay, so then demand function is just a function that describes how other things, how the variables that affect demand are classified. So a function that describes how much of a good will be purchased at alternative prices of that good, and related goods, and other income levels, and so on. So if you put all the things that affect demand, including the price, into a function, you can call that a demand function. If you make it linear, and we can call it a linear demand function. Okay, so this defines the relationship between quantity demanded and all the other things that affect demand in a linear fashion. And I think, let me see if I can. Yes, here we go. So this would be a nice example of a linear demand function. Okay, so QDX, where the notation here is the quantity demanded of good X, is a function of, so this is the price of good X. This is the price of the related good, like the substitute of the complement. M is the notation for income, and then I think H is kind of everything else. So all the things that affect demand can be written or defined in a linear fashion or simplification. Okay, so let's look at an example. Actually, let me see if I. Okay, well, I redid the examples with the conceptual and computational questions. So let's look at, when we get to the end of chapter 2, we'll look at some examples. Alright, so skip this. We'll do problems at the end of chapter 2. Alright, and then consumer surplus is the value consumers get from a good but don't have to pay for. And so I think when we get to producer and consumer surplus, we'll look at those together, because it'll show us. This is a nice way to show graphically how consumers get a benefit if they're willing to pay more for the market price. And so let me see if it's. Okay, so this is a nice way to show the extra benefit that consumers who are willing to pay more, and also helps you understand the different parts of the demand curve. So this is our demand curve for a good or service, this pink line, and this is the market price. Okay, what you can see is there's different portions of the demand curve. So here's the cutoff here. So the consumers on the demand curve that are below here, so this part, those consumers would only buy the good or service if it was below this price. So they're not buying the good. So these consumers below this point are not in the market because they're only willing to pay a lower price. So they're not buying it. Okay, and then these consumers up here, like this one, adding them all together. So these consumers are willing to pay a little bit more. So each time you go up the demand curve, there's a consumer who's willing to pay a little bit more for this good or service. So these individuals get a benefit because they're willing to pay more than the market price. And then this point is the other cutoff because nobody is willing to pay more than this price. So this is the max that anyone's willing to pay. This is the cutoff for people below the market price. And then okay, and then if you can sum all these benefits in monetary terms, this is the additional surplus or benefit that consumers as a whole get because they're willing to pay more than the price that's being decided by the market. So this is the extra benefit or consumer surplus that the market gets from having the price here. Alright, so as long as the price is lower than the maximum point on the demand curve here, there's going to be some consumer surplus. Okay, so let's look at the supply curve. Okay, so supply curve indicates the total quantity of a good or service that all producers in a market would produce at a given price, and holding everything else constant that also affects supply. So it's the same price and quantity axes, but you have a positive relationship between price and market supply. Alright, so here's your supply curve. Here's the price of a good or service. Here's the quantity. And as the price goes up, you'll see that the market supplies more because they, if they can sell the good or service at a higher price, that's more revenue for the firm. So each time the price goes up, you'll get current suppliers supply more, or some suppliers that were not in the market enter the market. But as a market as a whole, if the price goes up, you always see that the supply goes up. So there's a positive relationship between the supply of a good or service and the market supply. Okay, so here we go. So if there's a change in quantity supplied, that just means a movement up or down the supply curve. So if the price goes up, you go up the demand curve. If the price goes down, you go the supply curve. You go down the supply curve. So if there's a change in price, for example, if the price goes up, you go from A to B, or vice versa. So going up or down the supply curve, there's a change in quantity supplied. Okay, but if there's a change in supply, that means that something else that affects supply also changes, and that's going to cause a shift in the supply curve. We're going to have supply curve shifters. So if there's a change in a variable other than the price that also affects supply, then that is going to shift the supply curve. So let's look at some things that might affect supply and cause it to shift other than the price of that good or service. Alright, so these are a bunch of things that could affect the price. So you can have an input price change. So this, when someone asks about the wheat and the bread, so if you're looking at it from the supply side, you can say that if you're a seller of bread, that one of the inputs, or one of the main inputs to your final product is wheat. And so if that's input price and the price of wheat goes up, that makes it more costly to supply bread. So if input price gets more expensive in the inputting of your final product, that's going to make you decrease, or the market decrease supply, because it got more expensive to supply that good or service. And so increase in input prices causes a decrease in supply. Alright, so if there's some kind of technology or government regulation change, if there's a technological advance which makes it less costly to supply a good or service given the same input you're using, that's going to cause an increase in supply because of the breakthrough in technology. This one, if the number of firms goes up, that's more suppliers by default. Supply goes up. Substitutes in production, that depends on if you, so for example, like the wheat bread example, if you're using wheat and you're as an input price, but you have other options you can substitute, like, what else, how do you make, whatever goes into like gluten-free bread, it's not wheat, so you can use, or if there's another input that can be used to get to the final good, and that can be purchased for cheaper, that can affect your supply if you can switch inputs in production. For the producer side, if you have a tax on the output of the sale of the good, that's going to decrease supply because it got more expensive. You got to pay the tax for each unit sold. And if there's a change in producer expectations, like you don't know if there's going to be a demand for a service, or you maybe expect that it's going to be hard to get one of the inputs. Given what that is, that's going to affect supply as well. So if any of these things affect supply, that's going to shift the supply curve. And just notice that this way is a decrease, so going to the left or going up is a decrease. And going to the right or shifting outward is an increase. So this is an increase. This is a decrease. And you should see that if you stick to the initial price, if supply goes up, that means they'll supply more at the same price. If supply goes down, that means they'll supply less at the initial price. Okay. So we can also have a supply function, which relates market or quantity supplied to all the other goods, including the price, all the other variables or factors that affect supply, including the price, such as the price of the good, the input price, the tax, and so on. And if you put those in a linear relationship, you can classify a linear supply curve. A linear supply function, just like I'll show you here. Okay, so this would be a nice example of a linear supply function where QXS is the quantity supplied of good X. This is the price of the good. This is the price of an input. And what is W? W is W is the price of the input. Ty is the price of related goods. Yeah, so if one of the goods that affects supply goes up, you can put that in your linear supply function. And so this would show the market quantity supplied of good X as a linear function of all the other variables or factors that affect supply. Okay, so we'll skip this one again because again I redid the examples at the end of the chapter, so we'll look at some supply and demand examples at the end of chapter 2. Producer surplus is the extra value that producers or firms get from supplying. Okay, here you go. So here's the market price, 400 for an example, and then that hits the supply group here at point B. And so you can do the same analysis for supply that suppliers or firms that bought this price but only supply if the price was higher. So these suppliers are not in the market because the price is too low for them to do business. And then anything below point C is too low for any firm, so nobody's supplying at that point. So these suppliers are not in the market. Point C is the cutoff for any suppliers, and then these suppliers get a benefit in monetary terms because they would supply at lower prices than this. Okay, so each of these suppliers that would be willing to supply at a lower price gets a monetary benefit, and the sum of all those benefits is this triangle. And the sum of this estimation is called producer surplus because this is the total benefits that the market gets from supplying at this price. Because there's a lot of firms that are willing to supply at lower prices. Okay, so as long as the price is above point C, then there's some producer surplus. Okay, and then all right, we're almost done with the first session, but let me just finish the last couple slides, and we'll do the examples when we come back from our break. But market equilibrium. All right, so let's bring supply and demand together. And here we go. We got here's our price of goods and services. Here's our quantity of this good or service. And here's our downward sloping demand curve. Here's our upward sloping supply curve. And this is the portion or region in which supply equates to demand. Any price below that, we can see that if it was like just PL, price low, that would mean at that price, that demand exceeds supply, there would be a shortage because there's not enough suppliers that can fill this demand. At a price TH above, that is a high price above the market, and here, there's too many suppliers and not enough, so for the quantity supplied exceeds the quantity demanded, and we have a surplus. So if the price is too high, we have a surplus, where there's not enough consumers. And if the price is too low, we have a shortage, where the consumers cannot meet the demand curve because the price is too low. Alright, so this is the market equilibrium. Alright, so actually, it's 10:30, let's stop here, and we'll finish the rest of chapter 2. Alright, so we'll do the last few slides and the examples, then we'll do chapter 3, starting at 11 o'clock. So I'm just going to leave the meeting running, And I'd recommend doing the same. You can sign off, but make sure you sign back on. I'd recommend just staying signed on just in case there's an issue. But we'll start back at 11, take a nice 30-minute break, and we'll finish the rest of the class at 11. And thanks for joining, and we'll be back in 30 minutes.
Good.
Okay, thanks. Okay, you guys ready to do the second portion? Alright, so we'll finish where we left off on finish chapter 2, and then we'll do chapter 3. And we'll try to finish chapters 1, 2, and 3 for today. Okay, so let's finish up the PowerPoint for chapter 2. Okay, so we left off in market equilibrium. Let's look at briefly price ceilings and price floors. Okay, so since we understand market equilibrium, where the market forces put the price and quantity to equate supply and demand, let's look at a couple examples of a government-induced price. And so we'll look at price ceiling, which is a maximum legal price that can be charged in a market imposed by the local or state government. And we'll also look at a price floor, which normally applies to a minimum wage situation. Okay, so if this is a market, here's our supply curve, here's our demand curve, the price and quantity, and this would be the normal market price if there was no interference. You can see what might happen if there was a government-induced price ceiling, which made it illegal to charge above this price. So if there was no price ceiling, here's the market price, but this would be an effective price ceiling. So if this was a price ceiling, this price PC, we know that if it's below the market clearing price, that this is supply, and this is demand. So there's more consumers willing to buy at that lower price than there are suppliers. So we're left with a shortage in which at that price, here's demand that far exceeds the supply at that price, and so we have a shortage. And so normally if you have a price ceiling, you might get a shortage in the market because there's these suppliers who would supply at a higher price, and these demanders or consumers who would buy also at a higher price. So you lose part of the market. But there might be other reasons to impose a price ceiling. So a price ceiling might be used in a situation where you don't want the price to go above a certain amount. One common example one type of illustration that might be applied as an example to price ceilings would be possibly rent control. So rent control is an example of a price ceiling, and rent control works like the price is fixed. The price is fixed at a lower price and kept there until there's a change in the residence of a occupancy, like an apartment or housing rental. And so the rent control works that as long as the occupants don't move out, the price stays at the initial price. There's no increase in price unless there's a change in residence. So there's pros and cons of that type of problem. The pros are that rent is expensive, and if you get locked into a rent control situation, you don't have to worry about your landlord increasing rent, so it's more affordable. The cons, or the other side of this, is that usually in big cities where rent control happens, like Manhattan or Los Angeles or San Francisco, there's also a shortage of housing because the city keeps expanding with jobs and opportunities, but the city doesn't really provide a lot more housing. The housing expands, but outside of the city, like in the suburbs and the outside areas, but normally in the city itself, there's a shortage of housing. So you're trying to balance the situation between having affordable rent and a shortage of housing. So there's, different ways to look at the impacts of a price ceiling, but in terms of a supply and demand illustration, it looks something like this. Alright, so the other situation is a price floor. So this is when the government sets a price that's above the market clearing price. Alright, so an example of this, like I said in the PowerPoint, is minimum wage. Alright, so if this is a minimum wage situation, then these are the suppliers of labor, which are the workers. And this is the demand for labor, which is the firms and the businesses. Okay, and if they were allowed to agree in an open market, this might be the price they agree upon, because you can see that if TF is the price floor, like the price can't legally go below this, there's some workers who would supply their labor at lower wages, and there's some firms who would pay lower wages, but they can't because of the price floor. So you're left in this situation with a surplus in which at this price there's more suppliers, more people who would work than there were firms that would supply. So there's a surplus because the supply at that price, in this case the laborers, exceeds the demand, in this case the firms. So again, like the other situation, here's the microeconomic graphical problem with it. You're left with a surplus, but you also don't want a situation in which the minimum wage can go too low, that it's not, there's always arguments saying the minimum wage is not high enough, but there's arguments for and against the minimum wage. Against saying there's a surplus. For, you want to have a minimum wage in which people know they can get paid, and not have people working for $2 an hour. Okay, so what if so we looked at market equilibrium, we looked at the different price controls. Okay, so what if there's a change? What if we have a market equilibrium and a change in supply or demand of both? Then what happens to the new result after the shift or the multiple shifts? Okay, so we can look at a change in demand on equilibrium, a change in supply, or a change in both of the curves, which would affect things differently. Alright, so here's a nice example of just demand increasing. So if this is the price and the quantity of, in this case, rental cars, which obviously in the current state of the market, the demand for rental cars has gone way down. due to the current COVID-19 pandemic. But in this example, let's assume that the demand curve for rental cars went up. Okay, so we started here at 45 and 100, and the demand, the consumers are saying we'll pay more. There's an increase in demand for rental cars. And so if that's the case, demand shifts out. We go to point A, and the new equilibrium is, in this case, 49 and 104. And so if there's just an increase in demand, the result is a higher price and a higher market clearing quantity. Okay, what about if there's just a change in supply? So if we start with this equilibrium, point A, and in this case we're showing a decrease in supply. So if supply decreases, that means it shifts to the left or up. Okay, so whatever this is, let's say some input price goes up or something, or a tax causes supply to decrease. So if supply decreases, we go this way, a leftward shift, and the result is point B, and we go from P0 to P1. So if there's a decrease in supply, the result is a higher price and a lower market quantity. So that's, if one of the curve shifts from the equilibrium point, then it's pretty easy to figure out what's going to happen. But if both curves shift, like a lot of times there's things that affect both supply and demand. In that case, you got to kind of think through it. And let's look at that situation now in which we have both curves shifting. Alright, so if we have a simultaneous shift in supply and demand, that means that both the supply curve and the demand curve, both of them shift. Like the demand curve shifts somewhere, and the supply curve also shifts, because a lot of times a change affects both things. Alright, so it can become a little, messy when you're doing multiple shifts. And so I know in Viz 500B, we spent a bunch of time doing like the double shift analysis, where you shift one curve and then you shift the other curve twice. We're not going to do that whole analysis in this class, but this is kind of the idea that if both curves shift, you have to determine what you know for sure and what is undetermined, because it depends on which of the curves is a bigger shift. So here we have, let's see, looks like demand goes up and supply goes down. Both things happen. So see, if we start at point A, the effect on price. Okay, so here's what you can see from this analysis. So we know that demand goes up and supply goes down. So we don't know how much each of the shifts are. So what you can see is that in all cases the new price is going to be higher, and that should make sense, because if we start at point A and demand goes up, that means that the market will pay higher prices because of the increased demand. And if supply goes down, that means that the suppliers need to sell at higher prices to continue supplying. So both of those situations put upward pressure on the new price, so the price is going to go up. See? But we don't know which of these shifts is the bigger in terms of magnitude. Like if this decrease in supply is bigger, then the new result is a lower market quantity, or if this increase in demand is bigger in magnitude, then the result is an increase in market quantity. So if this shift is bigger, then this increases, or if this shift is bigger, then this increases. So we don't know, but you can determine for sure that the new price is going to go up. Okay, and so we don't have to do the whole graphical analysis for this class, but this table summarizes what's going to happen if you want to think through it. So there's kind of, if both curves are shifting, there's kind of four scenarios that can result. If there's an increase in supply and also increase in demand, then this is going to happen. You're not going to be able to determine the change in price. It's going to be ambiguous or indeterminate. But you'll know that if both supply and demand increase, there's going to be an increase in market quantity because both curves have increased. Okay? And like we just showed, we showed a situation up here where there's a decrease in supply and an increase in demand. If that's the case, you know the price is going to be higher, as we see here. But the final effect on the new market quantity is undeterminate or ambiguous because you're not sure which of the curves is bigger, which of the curve shifts is bigger in magnitude. Okay, in this result where there's an increase in supply and a decrease in demand, in that case, if both of the curves, let's see, so if supply goes up and demand goes down, then both of those situations put upward pressure on the new price because increase in supply means they're running the supply at lower prices, and a decrease in demand means they need to get lower prices to pay or continue buying this good. So both those things push the price down, and the result is definitely a decrease in price, but we don't know which of the curve shifts is bigger, so the result of the change in the new market quantity after the changes is ambiguous or indeterminate. Okay, and the final case is when supply decreases and demand decreases. So we know for sure that if both curves decrease, the new market quantity has to decrease because both the curves went down. We don't know what happens to price because if supply goes down more, that's going to push the price up, and if demand goes down more, that's going to push the price down. So whichever of those effects dominates or is the bigger in magnitude, that's going to be the result. So the point is that if you're faced with a situation in which both curves change, you want to think through it or look at this chart, and this helps you determine what the outcome is. In particular, what result you know for sure, and what result is ambiguous or indeterminate. It's the same thing. Okay, so this chart is a nice summary, so I'd recommend referring to this if you need to think through it. Does this chart make sense to everyone? What's happening to the new variables when supply and demand both shift? Okay. Let's Alright, so let's look at some examples for the chapter, the supply and demand questions. So let's look at question 6 and question 7, and I did those on the Word document. So if you go back to the chapter 1 document here. Sorry. Yeah, chapter 2 this time, because we're on chapter 2. So if you go to chapter 2, this is where I did the practice problems for supply and demand. So you can open up chapter 2. I think I already opened it up. Alright, so here is an optional video on supply and demand. that I put there, and there's some more explanation on price ceilings and price floors if you want to look at that as well. So those are, like I said, we're not going to watch videos via WebEx, but I'll give you a bunch of optional videos, and they're all pretty short. They're like 5 to 10 minutes, and so if you have extra time, you can look at the videos and explain some of the concepts in more detail and some more examples. All right, let's look at the conceptual and computational questions for number 6. And so this is at the end of chapter 2, and I think I modified the question slightly, but I used the equations they gave you. So here's demand and supply. Quantity demand is 50 minus P. It's a downward sloping relationship between price and demand in a linear fashion. And then quantity supplied is 1/2 P minus 10. So we have a linear supply curve and a linear demand curve, and let's use these to answer these simple questions. Okay, so you can solve for the equilibrium price and quantity with these two, the supply and demand curve. So all you gotta do is, if you got supply and demand, there's only one price and quantity in which the two are equal, so you gotta solve for those two things. Okay, so at equilibrium, we know that the quantity supplied and the quantity demanded are equal, so let's set the two equal and find the price at which that occurs. So 50 minus P equals 1/2 P minus 10, and there's only one price at which that happens. So let's add 10 to both sides, and let's add P to both sides. So yeah, 1/2 P plus 1P is 3/2 P, and then 50 plus 10 is 60. So we get 3/2 P equals 60, this little algebra, and then if you multiply both sides by 2/3, you get P equals 2/3 times 60. Other words, 120 divided by 3, and that comes out to our market price of P star is 40. Alright, and then quantity demanded equals 50 minus P, and quantity supplied equals 1/2 P minus 10, those are given. And you know that if you plug in the market price, you should get the same quantity for both things at equilibrium. If that's the case, then that's our market quantity. So let's plug in price equals 40 into both the supply curve and the demand curve and see if it's the same. 50 minus 40 and 1/2 40 minus 10. And here we get 10, and here we get 20 minus 10 for both situations. When P star is 40, demand is 10, supply is 10, so that must be the market quantity, or a market clearing quantity, 10. So the only situation in which supply and demand are equal is when price is 40 and quantity is 10. Okay, so, and then part B, state the effect of an increase. You don't have to draw the graphs here. Increase in demand and a decrease in supply. So what happens to P star and P star? So you can look at the chart if you want to double check this one. So you know if there's an increase in demand and a decrease in supply, right? So increase in demand, decrease in supply. So that should give us that we can work through, and we know the price is going to increase and the quantity is going to be indeterminate or ambiguous. Right, so quantity is indeterminate and price increases. Okay, so you can, if both the curves shift, you can just think through what happens and do the analysis, or you can look at the chart to double check. All right, so one more for supply and demand, number 7 at the end of chapter 2. We got two more linear supply and demand. We got QD equals 7 minus 1/2 T, and then QS equals 1/4 T minus 1/2. So we have a linear supply and demand curve. Let's use those two example curves to do the same analysis. All right, let's solve for the equilibrium pricing quantity, where set the two equal. We know that at equilibrium, QS equals QD. So 7 minus 1/2 T equals 1/4 T minus 1/2. Let's see. Let's add 1/2 T plus 1/4 T is 3/4 T, and then 7 plus 1/2 is 15/2, or 7.5. So then just multiply both sides by 4/3, and we get 4/3 times 15/2, and that simplifies to 60 over 6, which is a nice even price of 10. Okay, and then we got the price. Let's plug in the price into supply and demand. If it's equal, then that's got to be our market clearing quantity. So plug in 10 equal to, in the demand curve, 7 minus 1/2 T is demand, and then 1/4 T minus 1/2 is supply. Let's put in 10 in the both. 7 minus 1/2 times 10 over here, and then over here 1/4 times 10 minus 1/2. And this one simplifies to 7 minus 5. Supply simplifies to 2.5 minus 1/2. And in this case, we get 2. 2.5 minus 1/2 is also 2, so it must be that at 10, price of 10, Q star, or the quantity is 2. So we determined that the only price and quantity that's due this market is price of 10 and quantity equal to 2. Alright, and then part B, let's just state the effect of a decrease in demand and a decrease in supply, what happens to the new variables. So you can confirm with the chart that a decrease in both. Alright, so we should get that the price effect is ambiguous. We don't know which shift is bigger, but if both supply and demand decrease, we've got to get a lower market price. So we should get price is indeterminate, and the quantity change is a decrease. Okay. Any questions on the supply and demand example? Okay, so let me just, all right, looks like we're good. Let me just show you the homework assignments for chapter 1 and 2, and then we'll move on to chapter 3 in a minute. Alright, so if you open up on Blackboard under chapters 1 through 2, open up the homework chapters 1 through 2. Alright, so here's your homework for chapters 1 through 2, and you get one question on net present value. Alright, so you can use the example we did to help you with this one. you got one question on net benefits that we did in chapter 1. And then you got one question on supply and demand. So these should all be similar to what we just did for the examples of each. And you have my solutions you can refer to for the examples we just did together to help you with this. So homework for chapter 1 and 2 goes here.
And you said we can write out our answers, right?
Yes. So that's correct. So you can, let me show you where they go. So under discussions, here's the one for homework chapters 1 through 2. And so if you've done this before, you know what to do, but if not, you just go to here it is, the form for homework chapters 1 through 2 for this assignment. Once we're done with it, you can create a thread, and you don't need to you can put a title or whatever, but just attach your file that has your homework, and yeah, you can write it out, and I prefer if you submitted a PDF or a Word document, but if you can't do that, you can submit just a picture. So if you're going to do it in Word, submit the Word document. If you're going to do it by hand, like on graphing paper or blank paper, just try to convert it to a PDF and submit that. Or if you absolutely have to, I guess you can just take pictures of your work and post that. But I'd say PDF or Word documents, it's easier for me to view them. But if you can't do that, make sure you do something. All right. So everybody good on how to turn in the homework and what to do? So I don't care if you do it in Word or by hand, but try to post a PDF or Word document if you can. Okay, whatever's easier for you to do the homework. Okay, so we still got chapter 3 to do, and the elasticity homework which goes along with chapter 3, but we're done with chapters 1 and 2 for now. That homework goes there. When you're done with it, shouldn't take you too long, and that's due in 2 weeks, along with some other things. So I think this and this and this will all due next time, but you have 2 weeks, so you should have plenty of time to do all that stuff. Okay, so let's go on to chapter 3. All right, so let's go through so chapter 3 is about elasticity, and we're also going to do some data analysis in Excel for your homework, and then I have a couple data analysis homeworks. One of them is here, and then one of them comes in at chapter 9 or 10. But let's go through the PowerPoint for chapter 3 first to review elasticity. Okay, and then once you finish the material for chapter 3, we're going to do some data analysis in Excel. So if you have Excel available, you can try to do that with me, or just you can always it might be better just to watch now and then try to watch the video later and replicate it. But let me know if you have any issues doing the stuff again in Excel. So let's do the chapter 3 PowerPoint. So go to PowerPoint. Okay, like I said, this is recording. I'm going to post it on YouTube. But I just left it going to make sure I didn't mess anything up. And so during the breaks, there's just going to be 30 minutes of nothing happening. So if you're gonna rewatch the video on YouTube, when you get to the 2-hour mark, just fast forward for 30 minutes because nothing's going to happen. So just you have to go, you have an intermission for the videos too. Okay, chapter 3. Alright, so chapter 3 is on quantitative demand analysis, and that mostly pertains to elasticity. So here we're trying to learn that, depending on if you're a consumer or a firm, the respective elasticity of the good or service makes a big impact on your decisions and how it affects you, whether you're a consumer or a producer. Okay, there's an optional video here on elasticity. I've given you a bunch of optional videos, but just if you want to watch them, go for it. If not, we're not going to watch them in class, but there is some good material, and it helps explain some of the material and issues that we've covered so far. So there's one that explains some of the elasticity concepts some more. Okay, so let's review elasticity because this is what chapter 3 is all about, and then also the Excel homework we're about to do. Okay, so elasticity in general is a measure of the responsiveness of one variable to changes in another variable. Another way of saying that is the percent change in one variable that arises due to the percent change in another. So it's basically the percent change of something divided by the percent change of something else. So you're looking at how one variable affects the other. Normally it's something that affects quantity demanded or quantity supplied, and how a percent change in one thing leads to a percent change in another. Alright, so the most common type of elasticity, and the one we're going to spend most of the time on, or not most of the time on, but a majority of the time on, is the own price elasticity. And so this is like the general price elasticity of demand. So normally when you talk about elasticity, you're talking about this one. So this is the own price elasticity, also called just the price elasticity of demand. And so what this does is this measures the responsiveness of demand to price changes. So we know that the law of demand says or states that when the price goes up, demand goes down, and vice versa. But this shows you how much or what's the responsiveness. Okay, so this is a measure of the responsiveness of the change in demand to a given change in price. So in other words, it's the percent change in demand divided by the percent change in price. So how responsive demand is makes a big impact on both consumer and firm decisions, because sometimes the price change has a big impact, but demand changes a lot, and sometimes it has a smaller impact because the consumers aren't able to adjust to demand because they don't have a lot of options. So the certain type of good or service, you got to look at how elastic that is in response to price changes. So that's what we do. Okay, so the formal equation is, I think, let me find this here. Okay, so here's the notation in variable terms. So this is the way to express the price elasticity of demand in math-wise. So here, this is the own price elasticity of demand. So this is how changes in price, Px, affect the quantity demanded of X. So how Px affects Qx percent level. So another way of saying that is the percent change in the quantity demanded of X divided by the percent change in the price of good X. So what does the percent change in this cause in terms of percent changes in demand? So we're looking at how responsive demand is to changes in price. So that's the whole concept here is how does this change in response to this? Okay, so once you understand that, we have to classify goods as more elastic or less elastic. In other words, some goods will be called elastic and some goods will be called inelastic. And in particular, if the quantity demanded responds more than the price, it's more elastic. If it responds less responsive than price, then it's less elastic or inelastic. And so a nice way of drawing the cutoff is like this. Okay, so basically, demand is elastic if the absolute value of that own price elasticity calculation is greater than 1. So if this metric is bigger than 1 in absolute value terms, like if you take away the negative, then that means that this number had to be bigger than this number. And so demand was more responsive than price, and so it's elastic. Right? So it's in the elastic region because demand changed bigger than the price change. Now, if demand changes less, it's less responsive, or we call it inelastic. And so demand is inelastic if the absolute value of the own price elasticity is less than 1. So in other words, if this calculation is less than 1 in absolute value terms, then that means that demand didn't respond as much as the price change. So you can see that if this, like percent-wise, if this was 10%, which is 0.1, and this was 20%, which would be 0.2, then obviously the change in price was bigger, and this would be less than 1. So whichever the percent change is bigger determines if it's elastic or inelastic, because that's directly telling you if demand responds more or less than price. Okay, and then if demand is unitary elastic, if the absolute value of the own price elasticity is equal to 1, so that means if both of these are exactly the same, like if this changes 50% and this changes 50%, then it's going to be 1 because they're both the same. And so in that case, it's unitary elastic, meaning the both responses were identical. Alright, so let's look at how this relates to total revenue. And if you look at figure 3.1, which I think is the same in this older version, okay, yeah, so here we go. This is a really nice illustration of how demand changes, elasticity changes from point to point. So this here represents a linear demand curve, right? And you know that if that's the case, the effect of price on demand is always the same, but that doesn't mean the elasticity changes because the responsiveness or the change in demand relative to the price is not constant. So this is a nice way of looking at that. So let's look at here. So with any demand curve, or with most demand curves, your elasticity is going to change up and down the demand curve. So normally in the bottom region, it's more inelastic, it's less responsive. And normally in the upper portion, it's more elastic or more responsive. And then there's some point in which it flips in the middle. So once it goes from here to here, it becomes elastic and vice versa. And so let's look at how that affects the total revenue curve, which is this price times quantity. Okay, and so you can see that this is an example of total revenue. And you know the total revenue is just the price of the good times the quantity. Alright, so if we only have one good and it's selling for that price, then the revenue of the firm, we haven't talked about cost yet, we're just talking about revenue. If it's one good and it sells for that price, and the firm sells however many at that quantity, then the revenue is just how many they sell at that price. Okay? So, this is the revenue of an example of a firm, and so you can see that in the elastic region, because demand is more responsive than price, what the firm is doing is it's gaining more revenue by dropping the price because they're getting more customers from the competitors, or basically more customers are buying the goods at the lower price, and that offsets the revenue they lost by selling it at a higher price. But then, after this point, in this case it's 40, it becomes inelastic, and you can see that here's when demand is less responsive than price. And so what we're seeing here is that if they drop the price, they're losing revenue. So this demand curve is just an example, but it tells you what the firm should do. So if they can estimate a firm or a business that they're in the inelastic region of their demand curve, then to increase revenue, they should increase their price. If they're in this region, going this way increases your price because your consumers are less responsive than price, so the additional revenue you get from raising the price offsets the revenue you lost from losing a few customers. But over here, if you're in the elastic region, then you can increase your revenue by lowering the price because your consumers are too responsive. Okay, so if you're a manager of a firm, what you want to do to maximize revenue is, if you're in the elastic region, lower the price. If you're in the inelastic region, increase the price. And again, the cutoff for these regions is going to be different depending on the type of good or service. So if you have a steeper curve, then more of it's going to be inelastic, or if you have a flatter curve, then more of it's going to be elastic, but the concept here is the same. So what you want to learn from this, or take away from this, is that if a firm is in the elastic region of the demand curve, to increase revenue, they'd want to lower the price, versus if they're in the inelastic region of the demand curve, to increase revenue, they want to increase the price. So that's the main takeaway from this whole analysis here. All right, so everybody good so far? We all still following along? Okay. All right, so next slide 7. Let's look at the extremes of perfectly elastic versus perfectly inelastic, and then we'll look at we'll think of some examples of the types here. So if you look at figure 3.2, alright, so here is a perfectly elastic demand curve, which is this one. So that means that the demand curve is horizontal, meaning that the consumer responds 100% to any price change. So this means that if if there's a price higher than this point, you'll lose all the customers because they're only willing to pay this price. Okay, so this is when the consumers are 100% responsive to the change in price. And then this is the other extreme where the demand is perfectly inelastic. So in this case, there's no change in response. Right? So here, if price goes up a little bit, all the customers are gone. Here, if price goes up any amount, you still have the same amount of customers. Now these are extremes, and normally you have elastic and inelastic in the middle here, but it's important to see the extreme points and kind of think of what they might mean. So let's, just to make sure we understand the different shapes and elasticities, let's kind of write at least one example for each type. So first, we'll go from perfectly elastic to elastic to inelastic, and then to perfectly inelastic to make sure we understand the different types of markets. And for perfectly elastic, okay, so can you guys think of an example of a perfectly elastic good, which means that if they're basically like perfect substitutes, and so the consumers are only willing to pay this amount for the good or service, and if the price goes up above what they're willing to pay, then no consumers buy it. So can we think of an example of a perfectly elastic good or service?
Maybe like cleats, like for soccer players. Like if they're too expensive, you're not gonna buy them anymore.
So I mean, so you can use that example, but you have to say like perfect. That would only work if all the cleats are the same. And so let's say that like if you simplify it to saying that there's only one type of cleats and they're the same exact good, right? So there's only one. We say there's only one type of cleats. Like there's no different features. There's no brands. There's no features. They're all the same. So if that's the case, then yeah, all they care about is price, right? So it has to be something where you have to determine or classify as a perfect substitute. And so obviously there's options for cleats. You can buy more expensive ones, different brands, different colors. So if you have those choices, then you couldn't do it. But if you can simplify it and say like, this is a world where there's only one type of cleat, then yes.
Okay.
And so someone said toothbrushes, and so toothbrushes, again, so it's only if you're looking at an example where there's only one type of toothbrush to buy, and the only determinant is price. So the main thing is this has to be a perfect substitute.
I just Googled it. And it says cable TV service industry.
For perfectly elastic?
Oh, no.
Yeah, so, well, I mean, actually that would come into a different time, but, so for it to be perfectly elastic, you have to have perfect substitutes, so, all the goods are the same exact features and everything else. And it's not 100%, but a lot of times you can say that like the produce or the farmer's market agricultural, goods are similar. And so like if you're looking at the same, the best example is like if you go to a farmer's market and there's two sellers of like apples and they both sell the same exact apples, like there's no difference except where you're buying it. So it's the same exact apple, and one seller is selling it for $1 an apple, and the other is selling it for 75 cents an apple, then which one are you going to go to? You're going to go to the 75-cent seller because you're getting the same exact thing for a lower price. So you can do anything, but it has to be a simplification in which they're perfect substitutes. Okay. Did you have more on the cable TV?
No.
All right. Okay, so that's perfectly elastic. Now let's talk about, so most goods I would say come into the elastic region, or the elastic type, so, or let's say relatively elastic. Alright, so this is the easiest one to think of because most things you'll say will come here. Well, I don't know, but, so what's an example of a perfectly elastic good or service in which, most of the time the consumers respond more than the price because, so think of something that has, some substitutes and most of the time you can shop around. So what's an example of a, relatively elastic good or service? Yeah, so, I mean, most answers are probably gonna be right, but, alright, so it could be, so let's say like, alright, so things where you have options, to shop around. So, if you're looking at, if the price of a shirt gets raised, some people might still buy it, but most of the time if it goes up too much, you'll just buy a different shirt. Or if you're buying shoes, if some shoes get too expensive, you just buy a different pair of shoes. And the same with cereal. So things where you have a good degree of substitutability and you can shop around are going to be more elastic because the consumers have more options. Alright, so two more to finish the classification, but what's an example of a relatively inelastic good, which means that the consumers respond less than the price changes and are not very responsive. So if the price goes up, some consumers change or don't buy it or leave, but most of the consumers stay. So what's something in which a price change would cause little change in demand, and the main thing is that demand is less responsive than price. Yeah, so something like that, where you don't have to buy it, but there's not a lot of, so it's something where there's not a lot of substitutes. And so if you're driving a car or anything that operates on gas and the price goes up, you can not buy the good or service, but you don't really have another option to put in your car. So you can choose not to buy it, but a lot of times, or most of the time, if gas goes up or down, most consumers still purchase it because it's the only thing that can go into the car. There's examples where you have electric cars and stuff like that. You can take the bus, but normally we see that studies show that if the price of gasoline goes up, you lose some customers, but not very many. And the same goes for the price going down. All right, so last one here is perfectly inelastic. Okay, so what might be an example of a perfectly inelastic good, which means that, this is an extreme, but you have this is demand, and no matter what the price is, you have no consumers leave, so these consumers will pay any price for this good or service. So can we think of an example like this, where it's something that doesn't change, demand doesn't change with any price? All right, so something where your customers, basically life or existence depends on it. Like if you're a consumer of insulin or you need a very vital surgery, then, you're probably, this is an extreme, but it's likely you're not going to lose a lot of customers when the price goes up. And you could say the same thing right now about the vaccine for the coronavirus vaccine. That I think no matter what the price is, you're going to have some consumers that buy it. So these two are extremes, but it's important to see like what might go into this one and this one, whereas most things are in the relatively elastic or relatively inelastic. Okay, so figure 3.3, which shows marginal revenue. Okay, so what this shows is the relationship between what we talked about with the revenue and the different regions of the elasticity curve or range. So in the elastic region up here, marginal revenue is positive, and then below in the inelastic region it becomes negative. So what you're trying to do is, as a firm, the best place is when MR is 0. So if you're in the elastic region and you drop your price, you're increasing your revenue. Or if you're in the inelastic region, you increase your price, you're increasing your revenue on the margin. So this shows a nice relationship between the elasticity regions and the changes in revenue and how that changes on the margin. So you can see the MR goes along with the change in revenue. Okay, so a few more, there's some other types of elasticity. So one is the cross price, and this relates to the factors we talked about last time, which shift the demand curve. So the cross price is this. This is a measure of the responsiveness of the demand for a good to a change in the price of a relative good. Okay, so it's the percent change in quantity demanded divided by the percent change in the price of a related good. So this looks at the responsiveness of both substitutes and complements. So you can look at those in more detail, and so you know what happens to demand when the price of complements or substitutes changes. But this can show you the actual responsiveness if you're interested in that. Alright, so the income elasticity, and we're going to estimate this in some of the homework assignments or when we do some data analysis. We're going to look at how responsive the demand for a good is to income changes. So the measure of the responsiveness of the demand for a good to changes in income. In other words, the percent change in quantity demanded divided by the percent change in income. So we're looking at the same type of calculation, but here we're looking at how demand responds to income changes. Alright, so here the top part is the same, so we're looking at the effect, or how when income changes M, how that affects the quantity of X. So the percent change in quantity demanded of X divided by the percent change in income. So we can estimate this as well, but you can see that the top part is the same, so always looking at something that affects demand and how changing this affects the responsiveness of this. So we can estimate both of these things. We'll do that in a little bit. Alright, so you can take the linear demand curve that we defined in chapter 2, and you can use those specifications to determine the general form of the different elasticities. And so let's look at that. Alright, so here is what we introduced in chapter 2, which is a linear form of a demand function. Okay, so here's demand as a function of the price of that good, the price of some related good, of income, and a bunch of other stuff. If you wanted to estimate, in our case, we're interested in the own price elasticity, okay, which is the percent change in quantity demanded divided by the percent change in price. Okay, so it's basically this little AX, which is the linear, the effect or the slope of this in relation to this. So it's how you define a linear relationship between price and quantity demanded. And so if this is the slope, that's the change, right? So if you multiply the change times the original price and the original quantity, then that is the elasticity. So you can take this coefficient or the slope of each particular individual linear relationship, and all you gotta do is multiply that by the original price divided by the original quantity, and that is the elasticity. So the way to calculate the own price elasticity given the linear demand function is like this. You just take the coefficient for this, a subscript x, times px divided by qx. So this is how you take the linear demand function specification and define the elasticity. You can do the same for the other elasticities. Alright, so the cross price is this coefficient, or this linear slope between ty and qx. So take that, multiply it by the original py, and divide it by qx. Okay, and that's how you would define the cross-bias elasticity. And then, so the income elasticity, same concept. Take this coefficient or linear relationship between income and QDX. So alpha M, and multiply that by the original income and divide it by QX. So you can see the recipe here is always the coefficient times the original thing you're looking at that affects demand, and they're all divided by QX because you're looking at how that top variable affects quantity demand. Alright, so this is how you would define elasticities with a linear demand curve. And so we're gonna get to a more simplified version of estimating the elasticities. And so let's build up to that. Alright, so log linear demand function. So demand is log linear, and you'll see why we're doing this in a minute. Demand is log linear if the logarithm of demand is a linear function of the logarithms of price, income, and all the other variables that affect the demand function. So if we take the log, or the natural log, of all of the variables, and we define it in a linear equation, you can define it as a log linear demand function, kind of like this. Alright, so the little ln is the natural log, okay? So if you define it like this, it looks a little like a lot's going on, but this will help us estimate the elasticities when we get to that. So if the natural log of the quantity demanded of x is a function of all the other natural logs of the other variables combined, then you can define it like this big log linear demand function. So what we're saying here is it might take this form where the natural log of the quantity demanded of x is a linear function of the natural log of the price of good x plus the natural log of the price of good y, which is a related good, plus the natural log of the income, and all of these things are, it's a linear specification where the natural logs have a relationship between that variable and the natural log of 2x. Alright, and so the reason why we're gonna build up to defining the demand function like this is because if we can assume the demand can be estimated by this type of relationship, then we can estimate the elasticities with real data a lot easier. Alright, so let me show you what I mean here. Okay, here we go. So this is exactly what it is. Alright, so we've been looking at, for simplification, the linear demand function, which shows price and quantity as a linear demand function, like a straight line. But if you can, like this pink line here is a log linear fit, and so if we can make the argument that our data fits this curve line, then we can use a log linear specification, which is likely because it's often that the slope change, or in more extreme cases, it's the slope gets steeper here and flatter here. All right, so if you plot the data for a demand curve, the price and quantity, and you can make the argument like you have here that it fits this curve, the log linear relationship, then you can use the log linear estimation and all the properties that go along with it. So this pink line is what a log linear demand would look like, which looks like a demand curve, but not a straight line. Okay, so if we're specifying log linear demand, all we're saying is that the relationship is, it's downward sloping, but it's nonlinear and it follows this type of curve. Kind of, when it gets to really high prices, it gets very steep, and when it gets to really low prices, it's really flat, which is often what a real demand curve looks like. Okay, so let's get into why this relates to elasticity on the next slide here. Okay, so if we assume that the demand function is log linear, what does that mean? So that means that we can estimate the coefficients a lot easier to the elasticity. Okay, so let's look at how we can get the different elasticity estimates from a specific log linear function. Okay, and so what you'll notice is that when demand is log linear, the elasticity with respect to the given variables is simply the coefficient of the corresponding logarithm. And I'll explain why, but let's look at back to the log linear demand function and then the elasticity estimate. Okay, here we go. So here's what we talked about for the log linear function, and we know kind of what the shape looks like now. But the nice thing is that if you specify it like this, like a log linear demand, then these coefficients, like the coefficient for the natural log of price dy, or the coefficient for the natural log of py beta y, is exactly the elasticity. So if we specify it like this, and we estimate it, then these coefficients are equivalent to the respective elasticity. So this one is the own price elasticity, dx, and the one for py is the cross price elasticity, beta y, and the one for income is the income elasticity, beta m. Alright? And so the reason is, with the linear or the natural log specification, that your elasticity is always the same, and so it's kind of a nice trick where if you look at that graph one more time, okay, so if you specify it as such, if the properties work out that each time you go from this point, if you move along this curve, the elasticity is the same because of the way you specified the relationship. So if you have a natural log, the change is just so that the elasticity is always the same. Okay? And so it's kind of a nice, simplification. If you can assume that your data follows this type of curve, a natural log relationship where it's kind of, curved like this, then you can get the elasticities from the data a lot easier because basically the elasticity is always the same, right? Based on the way you define the natural log relationship. All right. So the point is that if you can make the argument that your data follows this type of demand curve and so on, then you can use the natural log function, and then the natural log function gives you the elasticity estimates, which can be used for any point along the demand curve. Okay, so what we're trying to do is we're gonna get some data when we do the analysis. We're gonna specify it or transform it to the log linear form because of all the nice properties that relate to elasticity, and then we can actually estimate the elasticity because of the way we specified it as a natural log linear function. So, everybody following along so far, I know this is, we call this some, nonlinear functions, but it helps. It's going to be a lot easier when we do the analysis, but, any questions on what we've done in the last 30 minutes? Okay, so we have a few more things to cover in the slides here, and then we're going to look at some data. All right, so we're going to, the point of this chapter is to take data on, so if we're estimating the own price elasticity of demand, we have a bunch of different prices and quantity demanded for some good or service, actual data points. So we use that to estimate the elasticity and determine how responsive demand is to different factors, and that's what we're trying to do. So we're going to do that by using log linear forms and some simple regression analysis. And so we're not going to spend too much time on this, but for chapter 3 we need to do it. And so we're going to do a little bit of regression or econometrics. And you might have learned this in the statistics course, but if not, we're going to cover the basics for what we need for this type of analysis. Okay, so we're going to use data to define a relationship between two variables and, like price and demand or demand and income, and then estimate the relationship based on the data. So the way you do simple regression is if you look at figure 3.4, you've probably done this before, but so a regression line or a simple econometric model looks like this, where you have this is Y, where you have price. Actually, let's say Y is demand because these are what's affecting demand. So this is demand, and let's say this is price. So, and then you're looking at the different data points. So this, let's say point A, when the price was this is what demand was, and when the price was this is what demand was. So you're looking at the different observations, what demand was at different prices. Okay, and then you're trying to fit a line that goes that minimizes those distances, so the best fitted line for this particular data. All right, so that's all we're doing in this regression line or econometric analysis is we're trying to pick the best line through the actual data and then use that to make, inferences about the relationship. Okay, so we'll do that by using this least squares regression procedure. And if you take in statistics or econometrics, you might have done this before, but I'll just explain the key points here. And that we're trying to fit a line that minimizes the sum of the squared deviations between the line and the actual data. So if you look at that picture again, these are the data points, A, B, C, D, E, F, and this is the line that minimizes these, right? You want to take all these differences from the line and minimize that distance. So if you take this plus this and square it, then this line would give you the smallest distance, or the smallest sum of the squared distance between those observations. Okay? So it's the method in which is the least squares is you're making a line that minimizes those distances squared. So basically this line is the best, and it gives us the smallest amount of this squared plus this squared plus this squared plus this squared, and so on. So this is a way of defining the best line that captures this relationship. Alright, so then the t-statistic is there's some measures to evaluate after you do the analysis, you have to interpret it and see what your data tells you. Okay. So the ratio of the value of the parameter estimate to the standard error of the parameter estimate is called the t-statistic. And so basically, the bigger this is, the better that your estimate is, or the more likely it is that it's true based on the data. And so you want a higher t-statistic. And so there's a whole, if you take statistics, you'll see it as a t-table and a chart you look at. But we'll just use a rule of thumb that basically as long as your t-statistic is bigger than 2, like the number 2 in absolute value, then it's good enough. So I'll write this here, but you want to check that when you get to the t-statistics, you want to check that those are bigger than 2 to confirm that your data actually shows the relationship that you're estimating. Okay, so you want to check to see if your t-statistics are bigger than 2 in absolute value. And if they are, that means that the estimate's good enough to make all the interpretations and conclusions from it. So the rule of thumb is 2. So you'll see what I mean, but it's a nice simplification. We don't have to use a table. And if it's bigger than 2, then that's good enough for this chapter. Okay, and then a few more things to evaluate your regression is to look at the R-square. So basically, we're going to do some stuff in Excel, and we're going to get a bunch of things to look like statistical numbers and metrics but I only want to look at a few things. So the R square is also called the coefficient of determination. Alright, so this is basically the fraction of the total variation in the dependent variable, which is going to be client demanded for all of our analysis. So the fraction of that that's explained by the regression. So it's explained variation divided by total variation. So you're going to get some number that's between 0 and 1. And if it's like okay, so if your R squared is 0.85, that means you explain that fraction of the total variation, so you explain 85% of the total variation in the dependent variable. Okay, so if that was the case, you would have explained 85% of the total variation in y, which is the variable that is being affected. Okay. So the closer it is to 1, if it's 1, it's 100%. That's the best you can do. If it's 0, you explain nothing, and it's probably going to be somewhere in between. Alright, so a few more things, and then we'll do some data analysis. So if you're looking at, another thing you can look at is called the F statistic. And so this is a measure of the total variation explained by the regression relative to the total unexplained variation. So it's how much you explain in relation to what was not explained. So the more you explain, the higher the F statistic because it's a ratio. So the higher it is, the more you explain. The lower it is, the less you explain. So this is a nice thing to look at because it can tell you the amount your estimation attempted or probably explained. Okay, so a few more things. So we're gonna specify our equation as log linear and estimate the analysis so we can estimate the elasticity. So we're gonna do a log linear regression line that we already looked at that in figure 3.5. Okay, so again, this graph's important because we're basically, if we can make the assumption that our data follows this type of curve, then we can easily interpret the elasticities by doing regression analysis. So that's the assumption we're making. Okay, in multiple regressions, this means that we're adding more than one x variable to our equation. So we're going to do something, we'll do some examples with price, income, and then advertising as well. Alright, so this is if you did just one variable, like in natural log is the natural log of quantity as a function of the natural log of price, and that's it. That's just that's single regression or simple regression. If you add any more variables, say like we did here, or if you had a second variable or a third, then it becomes multiple regression because you have multiple X variables, and so we're going to do some analysis with just the effect of price on quantity, and that's single regression or simple regression, and then we'll look at some that have price and income or advertising. So if we have more than one variable, more than one X variable, then it's multiple regression. If we have just one, it's simple regression. But the interpretation is similar. Okay, so let's close the PowerPoint here and look at let's try to do. All right, so these problems have been I transformed them into your homework for chapter 3. Okay, so let's go to the chapter 3 folder. All right, let's open up the homework for chapter 3. Okay, so I think what we'll do is this. The homework for chapter 3 is, so I don't know if we have time to do all the Excel data analysis by 1 o'clock. So here's what we'll do. We have to go through this because this shows you what your result would look like after you do the data analysis. So we'll do this, and that'll set us up for the Excel. Let me hold on 1 second. Okay, so here we are today. We did this, and I showed you guys the homework for chapter 1 and 2, which is due next time. So let's go through the homework for chapter 3 because I need to walk you through it. And I think I'm going to move the data analysis portion of elasticity to next time because I need another 30 minutes or an hour to do that, and I don't want to push you guys too far. But I think we'll have time to do it next time. So let's go through what you have to do for chapter 3, and then you'll have the homework chapters 1 and 2, and then you'll have the homework chapter 3 both through next time, and then we'll go through the Excel full data analysis for the elasticity homework, but that won't be due until probably meeting 3. So we'll move this to next time. Yeah. And then this will be pushed back because I kind of figured that the chapter 3 stuff takes a lot of time, and I want to make sure you guys are ready for the Excel portion. And so next time, we'll do that first. And so make sure you have access to Excel or, by next time, and then we'll do the Excel analysis together. But we still need to do this one first. All right, so let's go to the homework for chapter 3, and then for next time you just have to do the homework chapter 1 and 2, and then the homework chapter 3, and we'll push the data analysis and elasticity Excel work for next time. So this won't be due for next time, but these two will. All right, so we're still on pace to do everything. We just need to move some things around. All right, so I'm sure you guys are fine with that. Okay, perfect. Welcome. All right, so there's only one question, and we'll pretty much do it together, but this will help you prepare for what's going to happen. Actually, the homework, the elasticity homework is kind of long, so this will help us prepare for that. So this here, see the screen cap, this is what happens. This is what your spreadsheet in Excel will look like after you do the data analysis. So this will be a nice introduction to that before we actually do it together in Excel. So let's do this. Okay, and all right. So actually, one more thing before we do this is okay. So this is I wanted you to see this before we do it next time. So when you open up Excel,
I'm sorry, I can't see anything.
Okay, sorry, I didn't. Okay, can you see it now?
Yes.
Okay, thank you. All right, so this is just a blank Excel workbook, which we're going to be using Excel next time in the future. And so if you click on, I don't know, it might be a little bit different if you're using a Mac or Windows or whatever, but pretty much everything has this. If you click on the Data tab where you go to the Data Features, what we're going to be using is under the Data Analysis section. And I know that it's not always the default option. And so let me just show you how to if you're using any Excel version, most of them have this, but it doesn't always show up right away. And so I wanted to make sure that you guys have this for next time. So see that. If you don't see that, what you want to do is go to you want to just check it in the add-ins. So if you go to the File tab, this is for Windows. And you go to Options, and you want to navigate to Add-ins. All right, and then down here where it says Manage the Excel Add-ins, click on the Go button. Okay, and if your Excel has this feature, which it probably does, it'll say, see where it says Analysis Toolpath, it's the first one. All right, so a lot of times it's not checked, so you have to manually check it. And if you check that box and hit OK, then under the Data tab, you should see that you have the data analysis here in your Excel. And it's a little bit different for like the Mac, and I'm sure you guys can figure it out if you have it. So what I'm just trying to show you is before next time, check to see if you have the data analysis feature in Excel, or make sure you do. And if you have any problems with that, let me know beforehand, because then I can address it before. So just open up Excel sometime. You don't have to do it right now, and try to figure out how to load or just check the add-in for the data analysis. If there's any issues, let me know, and then I'll try to figure it out and help you before we do it next time. Yeah. So let's go through the chapter 3 homework, and that'll be the last thing for today. Okay, so here's the homework for chapter 3. Just one question, but it'll help us do the elasticity estimates. So let's assume that at a hypothetical cruise ship company, we get data on company sales, cruise prices, and then average income. So we're going to estimate this log linear relationship, which will be the natural log of quantity. Okay, as a function of the natural log of price, and also as a function of the natural log of income. So we're doing this so we can estimate the elasticities for both of those variables. So we're basically estimating the own price elasticity and the income elasticity. So that's the goal here. Okay, so LNQ is the natural log of quantity, LNP is the natural log of price, and LNI is the natural log of income. Okay, and then this might look unfamiliar now, but when you do the analysis in Excel, you're going to get a summary output tab that looks like this, where you get all the analysis from your data, your regression. Okay, and so you only need a few things to analyze the results, but this will help us here. So part A is using this. So here you got the R squared, you got the coefficients, and you got the T-stats, and that's really all. There's a lot of things you don't need to worry about, but everything you do need is here. Okay, so part A is let's write out the equation using the estimated coefficient. So basically we're going to start with this. And we're going to start with this general form, and we're going to put in the coefficients that we got from doing the analysis. All right, so let's start with this. Okay, so all we have to do here is use the coefficient estimates that we got to put into our equation. So here we go. All right, so the beta 0 is the intercept, and that's right here, 3.088. The coefficient for the natural log of price is right there, which is 0.004. Okay, so there we go. So this times this, so beta subscript P is the coefficient for LNP, which is right there, 0.004, and we got the one more for the income. And beta I, or the coefficient for income is this, 0.629. Times the natural log of income. All right, so all I did is this is the general form, but we got estimates now for these betas, which are the coefficients, so I put those in so we can make inferences about the actual relationship. So this is what you want to do, is use the coefficients you get to, reclassify your equation by just putting in the coefficients. Okay, part B is you want to interpret the adjusted R-square. The adjusted R-square is similar to the R-square that we talked about in the lecture, but it's better if you have multiple variables. Like if you have a multiple regression, then it's better to use this one. So interpret it just like we did up here in the discussion. So the adjusted R-square is 0.408. Okay, and again, that is the percent of explained variation that's captured by this regression equation. So if that's the percent explained, then we explained about 40.8%. Okay, so what did we explain here? So what's the dependent variable, or what's being affected? So we explained 40% of the variation in what? Okay, so the y variable is the natural log of quantity, so we explained 40% of that. Okay, so 40% of the variation in LMQ is explained by this regression equation. So when you get your adjusted R-squared, you can interpret it just like that based on the number you get. Alright, so for this part are the coefficients for the natural log of price and natural log of income, statistically significant. So that means you want to check if the t-stats are bigger than 2. That was our rule of thumb, and if they are, then you can say they're significant. If they're not, then they're not. So we're just looking at these numbers. So let me write them down here. Alright, so the t-stat for LNT is right here, 0.010, and the t-stat for LNI is right there, 5.902. So that tells us, that helps us determine our rule of thumb, that is bigger than 2 in absolute value terms. So this one. Okay, so obviously this number is way less than 2, it's like 0.01. So that's not enough. That's not big enough for us to make significance claim for that. So this one, the natural log of price, not enough evidence in the data to confirm this relationship is significant, but the other one is. Okay, so that just means that your data doesn't show there's a clear relationship between the natural log of price and the natural log of quantity. So you couldn't really make claims with your evidence about that. But for this one, there's definitely enough evidence to make claims about how income affects how the natural log of income affects the natural log of quantity. Okay, and then one more thing is you want to interpret, so regardless of the significance, you want to interpret the coefficients for the two x variables, so natural log of price and natural log of income. Okay, so here's your coefficient for the natural log of price. And so there's usually three statements or pieces of information you can give for these. So so the first thing is we're doing this for the elasticity estimate. So just state the type of elasticity that it is. So if it's the natural log of price and the natural log of quantity, then you're estimating the own price elasticity. Okay, and then you can classify it as inelastic or elastic based on the absolute value of the elasticity. So this one it's almost zero, so it's way less than one. So we know that it's not a very good beta fit anyways, but just to understand the number, if this is less than one, then it's inelastic. So this is definitely inelastic. Okay, and then the third thing you can describe is this is the actual responsiveness of demand to price. So this is what happens to demand in percent terms. So basically, you would say this. Okay, so this is always looking at how demand responds to a 1% change in the x variable, or 1 unit change. In this case, it's 1%. So we're always looking at these x variables changing by 1%, and then the coefficient is what happens to demand. So this is what happens to demand. So not very much. Okay, so this would mean that this is a cross-price elasticity. It's inelastic, and if price increases by 1%, quantity demanded increases by 0.004%. So this whole last statement, first of all, demand is going up. There's a positive relationship between price and demand, which doesn't make much sense. The response to this is super low, and this all probably has to do with the fact that the data is not significant. So I'm just showing you how to interpret it, strictly based on the number. But you can see that this statement doesn't make a whole lot of sense because you have a positive relationship between price and demand, which probably is not true, but that's what the number tells you. Okay, and then the one for income can also be interpreted. Okay, so here's the coefficient for income, which you know is the income elasticity. Alright, and so this number again is less than 1. So this is the responsiveness of demand to changes in income. So this is less than 1, which means it's inelastic. Okay, so last thing you want to do is again interpret this responsiveness of demand to the change in income. So stated similarly, but now you're looking at income. So this is, if income goes up by 1%, this is what happens, so this is how demand responds. Okay, so what this tells you is if income goes up by 1%, then coin demanded increases by 0.626%. So demand is less responsive than income, but this, you can see why this statement makes a lot more sense than this one, because it actually, it's quite possible that if income goes up by 1%, then you get more demand, but it goes up by, about 60% of that change. Alright, and so this is how you interpret this is how you write the equation. This is how you interpret the adjust R squared, determine if it's significant or not. And then this is how you interpret the coefficients based on the number, the output you get from the summary output. Okay, and so, we definitely did the homework for this chapter, but any questions on this? Because we're going to do a lot more, we'll do more of this in the chapter 3 elasticity homework, but any questions on what we just summarized for this homework? Okay, yeah, no problem. So, right, so we did it together. So, but if you have questions about this, let me know. And if when we get to when you have to do it yourself for the homework, then you can email me your questions, or we'll go through it again. But this is all you have to do for this homework. Okay, you're welcome. So let me summarize. We're about done. What time is it? Oh yeah, so we're just about done. Okay. Okay, so for next time, then you have 2 weeks, and so homework chapters 1 and 2. All right, so this one goes there. So put your homework for chapters 1 and 2 into this form, and just attach the file, and then put your homework for chapter 3, which we pretty much just did. So just put that homework for chapter 3. So turn in homework chapters 1 through 2, and homework chapter 3 into those 2 spots, and then don't worry about this. We'll do that next time. So next time we'll start with this, and then we'll do chapters 4 and 5 for next time. So just make sure you turn in the homeworks for chapters 1 and 2, and the homework for chapter 3 before next time. So you have 2 weeks, but just make sure you do that. And then assuming this works out, we'll continue with the same meeting type for the rest of the 4 meetings. So we'll do in 2 weeks, Saturday, June 27th, we'll do the same type, assuming that works, from 8:30 to 1 with a 30-minute break in the middle. Okay, so I'll send you guys an email because I'm going to change the WebEx meetings. And the one that's scheduled for now at 1 o'clock, just ignore that because we're not doing that. And I'll change it from 8:30 to 1. And I'll remind you guys that the elasticity homework is not due next time. Okay, so do homework chapters 1 and 2, do homework chapter 3. If you want to read up on the chapters of 4 and 5, you can do that. But that's what we'll be doing next time. Elasticity homework, we'll do some data analysis in Excel, and then we'll move on to chapters 4 and 5. And make sure you can access that data analysis feature in your Excel program. Okay, so everybody good before we wrap it up for today? Okay, so yeah, it's a little bit after 1, so I'll try to keep it to 4 hours, but if we have to go a little over, that's okay. And so that's it for today. If you have any questions, I'll stay on for a few minutes just in case. But other than that, if you're good on the homeworks and the material, you can go ahead and log off. I'll see you guys in 2 weeks. And thanks for joining. And if you have any questions, send me an email. I'm happy to help. Okay, so thank you.
Thank you.
Yes, Professor?
Yeah.
Oh, yeah, just submit the homework in the discussion for chapter 1 and 2. Do you see it?
Yeah, let me see. Yes, that's me.
Yeah, that's me. I did before the class, yeah. I reviewed the chapter 1 and 2.
Okay, yeah, I got you. You're good. Thanks.
Okay. So, I do it in the Word document format.
Yeah, that's perfect.
That's perfect? Okay. That's good. Yeah. Okay, thank you.
Okay, thank you. So we update today's lecture on Blackboard. Yeah, so I'll I'll put today's lecture on the YouTube channel, so click on the YouTube channel, and then you'll see today's lecture later today or tomorrow. Yeah, so check the YouTube channel later.